So I think in last class I explained regarding what is called PSC-PR theory. Okay, we have learned regarding valence bond theory and then valential electron pair repulsion theory. Actually, according to valence bond theory, it is not easy to explain the shapes and structures of covalent molecules. So to overcome that drawback, again VSC-PR theory has been introduced to explain the shapes, structures, and bond angles of covalent molecules. Okay. So here, based upon electron pairs present around the central atom, we can predict the shape. Okay, out of these electron pairs, there may be bond pairs and lone pairs. And these bond pairs and lone pairs, actually bond pairs occupy less space around the central atom as they are mentioned for two bonding atoms, whereas lone pair occupy more space on the central atom as they are meant only for the central atom or the atom, single atom. Okay, so here these electron pairs, whether they are bond pairs or lone pair, they are arranged in such a way so as to minimize the repulsions and to give maximum stability. That's why the shape and bond angles depend upon the arrangement of these electron pairs. Actually, this is the basis for your electron VSC-PR theory. Now, according to that, if there are only two electron pairs which are bond pairs, then they are arranged linearly with a bond angle of 180 degrees. Okay, three bond pairs, then trigonal planar with 120 degrees. Four bond pairs, they are arranged tetrahedrally. Okay, or five bond pairs trigonal bipyramidal, six bond pairs octahedral, seven bond pairs distorted octahedral structure. Okay, but among these electron pairs, even in some cases there may be lone pairs. Okay, always there will be repulsions between bond pair, lone pair, and lone pair, lone pair. So based upon the magnitude of electron repulsion, they are arranged. Okay, so and such that the shape of the molecule depends upon the arrangement of these electron pairs around the central atom. Already I gave. Okay, if there are if in three bond pairs, if in three electron pairs, if two are bond pairs, one is lone pair, what is the shape? Out of four, out of five, out of six, out of seven, if bond pairs and lone pairs are there, what would be the change in the shapes? Already we have explained in last class. Okay, but actually main you should remember here is in objective question, the molecule will be given. Okay, so predict the shape of the molecule. So or predict the number of electron pairs involved in the molecule, or predict the hybridization. Now let us discuss regarding hybridization. That is very, very important. So next is hybridization. So actually why this is proposed is, actually PSC-PR theory has only theoretical basis. Okay, actually it has no any practical proof. So that's why to overcome that, again hybridization theory is proposed. Actually this hybridization is also only hypothetical. Okay, only based upon some concepts. So they came into some conclusions, and those conclusions were made as a theory of hybridization. Actually, for this also there is no practical proof or practical background. So now coming to hybridization. So what do you mean by hybridization? Intermixing up of two or more atomic orbitals of nearly same energy, giving equal number of identical orbitals is called as hybridization. Okay, intermixing up of two or more atomic orbitals to form equal number of identical orbitals is called as hybridization. Okay, here identical means what? Identical means the newly formed hybrid orbital, they should be identical in energy, they should be identical in shape, and they should be identical in orientation. That is called identical. Okay, so here for hybridization to take place during the formation of a chemical bond, so here they should satisfy some rules to undergo some sort of hybridization. So the rules are, first one is the atomic orbitals of central atom or single atom will only undergo hybridization by forming a bond. Okay, so that means, for example, if you consider methane, here only the atomic orbitals of carbon will participate in hybridization, but not the atomic orbitals of carbon and hydrogen. Okay, that means the atomic orbitals of same atom, okay, or central atom must participate in hybridization. That is first rule. Atomic orbitals of two different atoms do not participate in hybridization. Only for a particular atom, the atomic orbitals will participate in hybridization. Second rule is these atomic orbitals must have nearly same energy. That means, for example, if you consider 1s, it cannot undergo hybridization with 2p, or 2s cannot undergo hybridization with 3p. That means they do not intermix. Okay, atomic orbitals of nearly same energy will participate in hybridization. That is 2s and 2p. Okay, 3s and 3p, or 3s, 3p, 3d. Likewise, they only participate. That means they must have nearly same energy. Okay, then third rule is after hybridization, we will get equal number of identical orbitals. Equal number. For example, if two atomic orbitals participate in hybridization, you will get only two hybrid orbitals. 3 will participate, you will get 3. 4 will participate, you will get 4. Likewise, equal number of identical orbitals will be formed. Okay. Then, these hybrid orbitals, always they participate only in sigma bonding. So mainly they participate in sigma bonding. That means they undergo overlapping on their internuclear axis. That's why they mainly participate in sigma bonding. Okay. Then in this hybrid orbital, electrons will be arranged. Electrons will be filled in this hybrid orbital as per your rules, which are to be followed for filling up of electrons in the atoms. Like that means these hybrid orbitals for filling with electron, they should also satisfy Hund's rule. They should also satisfy Pauli's exclusion principle, and they should also satisfy Aufbau's principle. Okay, that means these hybrid orbitals can also be filled with the electrons by following some rules like Aufbau's principle, Hund's rule, etc. That means first all hybrid orbitals must be filled with one electron. Later they should be filled with later pairing would occur. So likewise, they should satisfy some rules for undergoing hybridization. Okay, so this is regarding hybridization. So now in our chemical compounds, covalent molecules or covalent species, generally we can observe some type of hybridizations. Example, sp, sp2, sp3, sp3d, sp3d2 and sp3d3 type of hybridization. Okay, so here coming to sp hybridization, the name itself indicates that here one s orbital and one p orbital of nearly same energy, they mix together, forming how many hybrid orbitals? 2, because here 2 are participating. That's why you will get 2 hybrid orbitals. But how these hybrid orbitals will be oriented around the central atom? They must be oriented in such a way so as to minimize the repulsions. Okay, because these hybrid orbitals will also have electrons and they will participate in bonding. That's why here again these hybrid orbitals are arranged in such a way so as to minimize the repulsion and to give maximum stability. Okay, so here as only 2 sp hybrid orbitals are formed, so if you observe the percentage s and p character, so they will have 50% s character and 50% p character. And these hybrid orbitals, they are arranged linearly. So they are arranged linearly around the central atom with a bond angle of 180 degrees. So that means in any case, if you observe the central atom undergoes sp hybridization, so then the percentage S character is 50, P character is 50, and they will be arranged linearly with a bond angle of 180 degrees. Okay, that's why the shape of the molecule depends upon what? Depends upon type of hybridization. The bond angle depends upon what? Type of hybridization. Okay, so that is sp. Now coming to sp2. What is sp2? 1 s and 2 p orbital. They intermix together, thereby forming how many hybrid orbital? 3 sp2 hybrid orbital. So out of these 3 sp2 hybrid orbital, they are arranged in trigonal planar array. Trigonal planar arrangement. Okay, with a bond angle of 120 degrees. Okay, so here if you observe the S and P character, it will have 33.33% S character, whereas 66.66% P character. Okay, So that is regarding sp2 hybridization. Then sp3 hybridization. What is sp3? 1s and 3p orbitals of nearly same energy will intermix together, thereby forming 4 sp3 hybrid orbitals. Because total 4 are participating, that's why you will get 4 hybrid orbitals. So how they are arranged? They are arranged tetrahedrally. They have tetrahedral symmetry with a bond angle of 109 degrees 28 minutes. Okay, what is S character here in this hybrid orbital? 25% S character and 75% P character. This is regarding sp3 hybridization. Similarly, we have sp3d, sp3d2 and sp3d3. What is sp3d? One is 3p and 1d orbitals of nearly same energy. They intermix with each other, thereby forming 5 sp3d hybrid orbitals. How they are arranged? In trigonal bipyramidal arrangement. Trigonal bipyramidal arrangement. Okay. So in this trigonal bipyramidal arrangement, 3 bonds are present axially, whereas the 2 bonds are present equatorially. Okay. So the axial bond angle is 120 degrees. Okay. Then the bond angle between equatorial and axial is 90 degrees. Okay. So here axial bond length are smaller, while equatorial bond lengths are more longer. Equatorial bond lengths will be longer. So this is regarding sp3d. Then sp3d2. What is sp3d2? One is 3p and 2d orbitals of nearly same energy will intermix, thereby forming how many hybrid orbitals? Total 6. Okay, these are 6 hybrid orbitals. They are arranged in octahedral arrangement. Octahedral arrangement with a bond angle of 60 degrees. Okay, so here all the bond lengths are same in octahedral arrangement. Then coming to sp3d3, here one is 3p and 3d. They intermix with each other, thereby forming 7 sp3d3 hybrid orbitals. Okay, how these are arranged? In the form of distorted octahedron. Distorted octahedron or irregular octahedron. Okay, so this is regarding hybridization. So hybridization means intermixing up of 2 or more atomic orbitals of nearly same energy forming equal number of identical orbitals. Okay, identical orbitals means they are identical in energy, they are identical in orientation, and they are identical in shape also. Okay, then coming to type of hybridization, sp, sp2, sp3, sp3d, sp3d2, sp3d3. Okay, but here we must remember that the atomic orbitals of same atom will participate in hybridization. Okay, they must have nearly same energy. Then equal number of hybrid orbitals will be obtained, and these hybrid orbitals are filled as per the rules which are followed for the filling up of atomic orbitals with electrons. Okay, and these hybrid orbitals are arranged in such a way so as to minimize the repulsions and to give maximum stability. That's why the shape and bond angle of the molecule depends upon the type of the hybridization. Okay, so now coming to sp, sp2, sp3, sp3d, d2, d3, sp linear arrangement bond angle 180 degrees, sp2 trigonal planar arrangement 120 degrees, sp3 tetrahedral arrangement with a bond angle of 109 degrees 28 minutes, sp3d trigonal bipyramidal with bond angles 120 and 90. Okay, sp3d2 octahedral arrangement with bond angle 60 degrees, whereas sp3d3 distorted octahedral. Okay, here bond angles are also distorted due to repulsions. Got it? So this is what is called hybridization. So now we should go for prediction of hybridization. This is very important. Prediction of hybridization of the given atom in the given molecule or ion. Okay, so this hybridization can be predicted in the different ways. So the first way is by using number of sigma bonds. By using first method is number of sigma bonds. So depending upon the sigma bonds around the central atom, you can predict the type of hybridization. Okay, number of sigma bonds and lone pair of electrons. Depending upon the number of sigma bonds and lone pair of electrons around the central atom, you can predict the type of hybridization. Okay, so now around our central atom, if there are 2 sigma bonds, if there are 2 sigma bonds. Okay. So then the type shape will be linear and the type of hybridization will be sp. Got it? Then 3 sigma bonds. The shape is trigonal planar with hybridization sp2. Or out of here 3 sigma bonds are 2 sigma bonds plus 1 lone pair. 2 sigma bonds plus 1 lone pair are there. Then also it is sp2 hybridization. Okay. Then 4 sigma bonds sp3 hybridization or 3 sigma bonds plus 1 lone pair. Okay. It is again sp3 hybridization or 2 sigma bonds plus 2 lone pairs. Again it is sp3 hybridization. Okay. Similarly, sp3d, when it can be predicted as sp3 around central atom, if there are 5 sigma bonds, total 5 sigma bond, sp3d, or 4 sigma bonds plus 1 lone pair. Okay, then it is sp3d, or 3 sigma bonds, 2 lone pairs, sp3d, or 2 sigma bonds, 3 lone pairs. Even it is sp3d hybridization. Likewise, depending upon the number of sigma bonds and lone pairs around the central atom, you can easily predict the type of hybridization involved in the given atom. Got it? So that's why first you should write the Lewis dot structure for the given molecule. Then you can easily predict what is the type of hybridization involved. Okay. So for example, if you are provided with what is called H2O molecule. H2O molecule is given. What is the type of hybridization of oxygen in H2O based upon this method? So here first we should write the Lewis dot structure for oxygen. So if you write the Lewis dot structure for water molecule, this will be the Lewis dot structure. That means here around oxygen atom, how many sigma bonds are there? 2 sigma bonds are there. How many lone pairs are there? 2 lone pairs. That means total how many are there? 4 sigma bonds or 3 sigma bonds, 1 lone pair or 2 sigma bonds and 2 lone pairs. Okay, that means it is equal to what? sp3 hybridization. Got it? Here see. All 4 sigma bonds or 3 sigma bonds, 1 lone pair or 2 sigma bonds and 2 lone pair. Then what is the type of hybridization we can predict? sp3 hybridization. Okay, that's why the central atom O has sp3 hybridization. Got it? So for example, if you are provided with ammonia molecule, what is the Lewis dot structure for ammonia? This would be the Lewis dot structure for ammonia molecule. That means total how many sigma bonds and lone pairs are there? 3 sigma bonds and 1 lone pair. Okay, that means total number of electron pairs 4 or 3 sigma bonds and 1 lone pair. Based upon that, you can predict that it is what is called sp3 hybridization. Okay, for example, if methane is given, what is the type of hybridization of carbon in methane? How can you predict? So here, so the structure of methane according to Lewis dot structure is this one only. That means around carbon total how many sigma bonds are present? All 4 sigma bonds. That means it is also sp3 hybridization. Okay. For example, if you are provided with carbon monoxide molecule, carbon monoxide. Okay. What is the type of hybridization of carbon in carbon monoxide? First, we should write the Lewis dot structure. So, total how many electrons are participating in carbon monoxide formation? Valence electrons, C plus O, 4 plus 6, 10. So, like that's why first you should write like this. If you write like this, 2, 4, 6, 8, 10, 12, 14, that means it has less electrons than required. So, that's why first to write one double bond. 2, 4, 6, 8, 10, 12. No, only we have 10 electrons. So that's why, so this would be the structure. That means this C triple bond O. On oxygen, there is 1 lone pair. On carbon, there are 2 lone pairs. What is the type of hybridization of carbon in CO? If it is asked, how can you predict? So here, how many sigma bonds are there? In a triple bond, in a multiple bond, only 1 will be sigma bond. Other 2 will be automatically pi bond. So that means here 1 is sigma bond. How many lone pairs are there? 2 lone pairs. This one, this one. So total how many? 1 sigma bond plus 2 lone pairs. Okay, 1 sigma bond plus 2 lone pairs. If it is there, so then also it is sp hybridization. 1 sigma, sp2 hybridization. 3 sigma bonds. All 3 sigma bonds. sp2, or 2 sigma bonds and 1 lone pair, sp2, or 1 sigma bond plus 2 lone pairs, then what is the type of hybridization? sp2. Okay, so in that way, oh sorry here, total 10 na, 4 plus 6 10, 2 4 6 8 10 12 అవుతుంది. So here only sorry 1 sigma bond and 1 lone pair. So 1 sigma bond and 1 lone pair, what is the type of hybridization? So 2 sigma bonds linear sp, or 1 sigma bond and 1 lone pair, 1 sigma bond and 1 lone pair, then also it is sp hybridization. So that's why what is the type of hybridization of carbon in carbon monoxide? 1 sigma bond plus 1 lone pair. Got it? So now I'll give the list first. Okay, so number of sigma bonds and lone pairs, based upon that you are predicting. Okay, 2 sigma bonds sp, better to take 2 sigma bonds sp, or 1 sigma bond plus 1 lone pair sp. Okay, then 3 sigma bonds sp2, or 2 sigma bonds plus 1 lone pair sp2, or 1 sigma bond plus 2 lone pairs sp2. Okay, so then 3 sigma 3 అయిపోయింది కదా. Shapes also linear, trigonal planar, or next what is called 4 sigma bonds sp3, 3 sigma bonds plus 1 lone pair sp3, 2 sigma bonds plus 2 lone pairs sp3. Okay, so like that you can predict. Okay, 1 sigma plus 3 lone pairs, then also it is sp3 hybridization. Okay, so this is like that. Similarly, 5 sigma bonds sp3d, 4 sigma bonds 1 lone pair, 3 sigma bonds 2 lone pair, 2 sigma bonds 3 lone pairs. Okay, so 1 sigma bond 4 lone pair. Likewise, if you consider, then it is sp3d. Likewise, you can predict. Okay, so now I am giving the example for carbon monoxide. So what is the Lewis structure for carbon monoxide? Carbon has 1 lone pair and oxygen has 1 lone pair, because total 10 electrons are participating. That means what is the type of hybridization of carbon in CO? 1 lone pair plus 1 sigma bond. So 1 lone pair plus 1 sigma bond means what is the type of hybridization? sp. Okay, then for carbon dioxide. Okay, so for carbon dioxide, what is the structure, resonance structure of CO2 molecule? C double bond O, C double bond O, 2 2, then 2 2. Okay, so total how many electrons are participating in CO2 formation? So carbon 4, 6 plus 6 12, 12 plus 4 16, 2 4 6 8 10 12 14 16. So this would be the structure. Okay, so now predict the hybridization. So here around carbon, how many sigma bonds are there? 2 sigma bonds. There are no lone pairs. Okay, that's why what is the type of hybridization of carbon in CO2? It is again sp hybridization. Got it? For example, if you are asked to find the type of hybridization of carbon in CO3 2 minus ion, CO3 2 minus ion, then how can you predict? Again, you should write the Lewis structure. Then again you can predict the type of hybridization. I think it is clear. Okay, so now let us see CO3 2 minus. How can you write? So here in CO3 2 minus, there is a double bond between so total how many electrons are participating? So carbon how many? 4. Okay, oxygen is 6 6 3 are 18 plus 2 electrons because charge. So total how many? 24 electrons. 2 4 6 8 10 12 14 16 18 20 22 24. Okay, so this is the structure of Lewis structure of CO3 2 minus ion. What will be the type of hybridization of carbon now? So on carbon there is no lone pair. Total how many sigma bonds are there? 3 sigma bonds. If 3 sigma bonds are there, okay, then what is the type of hybridization? sp2. 3 sigma bonds or 2 sigma bonds 1 lone pair, and 1 sigma bond 2 lone pair, then what is the type of hybridization? sp2. Okay, like that you can predict the type of the hybridizations. Okay, so this is regarding hybridization. Okay, this is first method based upon number of sigma bonds and electron pairs. Second method is, so by determining H or Q value, in some books H will be given, in some books Q will be given. Okay, H or Q is nothing but total number of electron pairs. Total number of electron pairs. How it can be predicted is H or Q is equal to number of electrons. Number of half into H is equal to half into number of electrons in valence shell of an atom when it is in free state. In free state, take down the formula. Okay, in free state plus number of monovalent. Number of monovalent. So here you should find H or Q. H or Q is nothing but total number of electrons. Okay, total number of electron pairs. Sorry, total number of electron pairs is equal to half into number of electrons in valence shell of an atom in free state plus number of monovalent surrounding atoms. Monovalent surrounding atoms. Number of monovalent surrounding atoms minus charge of cation plus charge of anion. Okay, so this is the formula. By using this, you can easily predict. Okay, so what is that? H or Q, total number of electron pairs is equal to half into number of electrons in valence shell of an atom in free state plus number of monovalent surrounding atom minus charge of cation plus charge of anion. Okay, so if H or Q is equal to 2 sp, okay, H or Q is equal to 3 sp2, 4 sp3, 5 sp3d, 6 sp3d2, 7 sp3d3 type of hybridization. By that you can predict. Okay, so now let us tell you examples. For example, if you want to find the type of hybridization of carbon in carbon tetrafluoride. Carbon in carbon tetrafluoride. So first you should find H value. Okay, how can you find half into this? So half into, so number of electrons in valence shell of an atom in free state. So how many number of electrons are there in the valence shell of carbon in free state? 4, because it is 4 tetravalent. Plus number of monovalent surrounding atom. So here chlorine is monovalent only. So that's why, so chlorine monovalent means total how many atoms are there? 4 atoms. 4 plus 4 minus 0 because cation, no anion here because it is a neutral molecule. Minus 0 plus 0. Okay, then half into 8. That means it is 4. H is equal to 4. If total number of electron pairs are 4. Okay, so then what would be the expected hybridization? sp3. Because if H is equal to 2 sp, 3 sp2, 4 sp3, 5 sp3d, 6 sp3d2, 7 sp3d3 type of hybridization. Okay, so that means for few molecules you can use this method to find the type of hybridization. For few methods you can use that is the total number of sigma bonds plus lone pair of electrons. Based upon that you can predict the type of hybridization involved. Okay, so for example, if you are provided with what is called OCl minus. OCl minus. What is the type of hybridization of oxygen in OCl minus? If it is asked, how can you find here? So here oxygen is central atom. Okay, then how can you predict? First you should find H value. That is half into oxygen atomic valence is 6 plus how many monovalent? 1. Okay, minus 0 plus 1 because minus 1 charge of anion is minus 1. So that is plus 1 charge. Okay, Then what will be the test? 6 plus 1, 7. 7 plus 1, 8. 8 by 2 means 4. So that means by H is equal to 4 means what is the type of hybridization? Again, it is sp3 hybridization. Okay. So for example, I'll give some examples. You please do. Okay. I'll give some examples. Find the type of hybridization involved. Find the type of hybridization involved in PCl5, PCl5, phosphorus in PCl5, oxygen in OF2, chlorine in ClF3, xenon in XeF4. Xenon in XeF4. Predict. So here what is H for P? P in PCl5. H is equal to half into, so here number of electrons in valence shell 5. Okay, plus 5 plus 0 minus 0. That is 5 plus 5 by 2, 10 by 2. That means 5. So the H is equal to 5 means what is the type of hybridization? sp3d. Okay. Then Cl in ClF3. Cl, how many valence electrons? 7. 7 plus 3, 10. 10 by 2. Again, it is also sp3d. sp3d. Okay. Then in OF2, what is the hybridization of oxygen in OF2? So oxygen 6 plus 2, 8. 8 by 2, 4. 4 means sp3. sp3. 4. 4 means sp3. Is it understood or not? Based upon H value, you can predict. If H is equal to 2, sp. If H is equal to 3, sp2. If H is equal to 4, sp3. If H is equal to 5, sp3d. If H is equal to 6, sp3d2. If H is equal to 7, sp3d3. Okay. So now I have already I gave even XeF4. What is the type of hybridization of xenon in XeF4? Xenon valence electrons 8, half into 8 plus 4 plus 0 minus 0. So that is 12 by 2. 12 by 2 means 6. So if H is equal to 6, what is the type of hybridization? sp3d2. Okay. Like that you can predict. Then you can also predict what is called if central atoms are surrounded by what is called divalent atoms, then how can you predict? Then also you can predict. So that is XeO3, for example, if it is given. Okay, how can you predict the type of hybridization? By using this only. So how can you predict here? So here, how can you predict? Here. So if you are asked to find how many bond pairs and lone pairs are present in on Xe in XeO3 molecule, or predict the type of hybridization. How? So here by again by using H value. H is equal to what for XeO3? H is equal to half into 8 plus 0, 0, 0, because all are 0. Because monovalent atoms are 0 only, because the oxygen is a divalent. So half into 8 means 4. 4 means what is the type of hybridization? sp3. Got it? So, but here in XeO3, sp3 means total how many sigma bonds may be formed? 4 sigma bonds. So that's why 1 bond, 1 bond, 1 bond. But 4 sigma bonds are 3 sigma bonds and 1 lone pair. So that's why Xe atom, what will be present? 1 lone pair. 3 bond pairs and 1 lone pair. Got it? Because only 3 oxygen atoms are there. 3 oxygen atoms are bound through what is called 3 sigma bond. So that's why one hybrid orbital will be present with lone pair. That's why total how many bond pairs are there here? Say the 6 sigma bond pairs and 1 lone pair. Like that you can predict. Okay. So for example, if you are asked to find what is called XeOF2. What is the type of hybridization in XeOF2? Tell me. Xe10 plus 2 by 2, that is 6. 6 means what? sp3d2. In XeOF2 there is sp3d2 hybridization. So in sp3d2 hybridization, how many bonds are present here? F, okay. So then double bond O. 3 bond pairs are over. So then how many lone pairs will be there on its xenon atom? There would be 3 lone pairs. Okay. Likewise you can predict, because likewise you can predict the shape and number of lone pairs and bond pairs. Okay. And now I'll give one more example for ions. SO4 2- ion. Predict the type of hybridization for SO4 2-. Predict for SO4 2-. For SO4 2-. Half into S6 plus 0, because it is divalent. Monovalent are 0. Okay. Plus 0 cation charge. Minus 0. Okay. Minus 0 plus 2, because anion charge is 2. That means 6 plus 2, 8 by 2. 8 by 2 means 4. 4 means what is the type of hybridization? sp3. Okay. So likewise, NO2- ion. What is the type of hybridization in NO2- ion? Make it fast. So N5 plus monovalent atoms 0, because oxygen is divalent. That you should remember. Okay. So 5 plus 0 minus 0 plus 1. 6. 6 by 2. 6 by 2 means 3. 3 means sp2 hybridization. Okay. So likewise you can predict. Okay. Next, in H3O plus. Find in H3O plus. What is the type of hybridization of oxygen in H3O plus? Half into oxygen central atom. Okay, that's why 6. Okay. Plus how many monovalent? 3. Plus 1 minus 0. That is 6 plus 3, 7 plus 1, 8. 8 by 2. That is 4. So what is the type of hybridization? sp3. Minus charge of cation. Yes. Then minus 1 plus 0. 6 plus 3, 7. 7 minus 1, 6. 6 by 2 means 3. 3 means sp2. So likewise you can predict. Okay. For example, if it is given OH minus, what is the type of hybridization of oxygen in OH minus? Oxygen 6 plus 1 minus 1 plus 1 minus 0 plus 1. 6 by 6 plus 1, 7 plus 1, 8 by 2, 4 sp3. అర్థమవుతుందా? Next, I3 minus లో కనుక్కొని చూద్దాం. What is the type of hybridization of iodine in I3 minus? And H you should find. H is equal to half into I. I means halogen. So the valence is 7. 7 plus 3, because it is also monovalent. All halogens are monovalent. 7 plus 3 minus 0 plus 1. 10 plus 7 plus 3, 10. 10. So sorry, here one. Only 2 now. You should take 2, because one I will become central atom. Got it? One I will become central atom. Okay, then only there would be 2 surrounding atoms. That's why in I3 minus you should consider only 2 surrounding atoms. Iodines are surrounding atoms. 7 plus 2 minus 0 plus 1. That is 9 plus 1. 10 by 2 means 5. Got it? అర్థమవుతుందా? I3 మైనస్ లో ఒక ఐ సెంట్రల్ ఆటమ్ కదా, కాబట్టి ఇంకా సరౌండింగ్ ఆటమ్స్ ఎన్ని ఉంటాయి? ఓన్లీ 2 ఉంటాయి. నాట్ యూ షుడ్ కన్సిడర్ as 3, all 3. Got it? So then 5 means sp3d. ఓకే. ఒకవేళ ఓజోన్ ఇచ్చాడు అనుకోండి, ఓజోన్ ని కనుక్కోండి, ఆక్సిజన్ ని. సో ఇక్కడ ఒక ఆక్సిజన్ సెంట్రల్ ఆటమ్ అవుతుంది, ఇంకా మిగిలిన 2 సరౌండింగ్ ఆటమ్స్ అవుతాయి. Kabatti, what is the hybridization of oxygen in ozone molecule? Half into 6 plus 0, 0, 0, 0, अन्नी 0, 0, 0 ने अंते kada. Divalent. Oxygen surrounding atoms are divalent. Oxygen is divalent. So kabatti enta avutundi half into 6 plus 0 plus 0 minus 0 plus 0. So that is half into 6 means 3. 3 means sp2. That means in the formation of ozone, the oxygen atom would undergo what type of hybridization? Only sp2. Got it? అర్థమవుతుంది అందరికి. So this is what is called type of hybridization. For example, if it is given ICl minus, very important, వీటి మీద గ్యారెంటీ ఒక క్వశ్చన్ వస్తుంది మీకు. ICl minus, I should be central because large atom should be central always. One chlorine monovalent. So here 7 plus 1, 8. 8 plus 8 minus 0 plus 1. 9 by 2. 9 by 2 means not ICl minus actually kada. ICl minus second form of only ICl, interhalogen compound. ICl, not ICl minus. So ICl minus means 7 plus 1, 8 by 2. That is 4 sp3. Okay. So likewise it may be asked. Okay. అలా కాకుండా కొన్నిటికేమో లూయిస్ స్ట్రక్చర్ రాసుకోవాల్సిన అవసరం ఉంటుంది. ఓకే, ఫర్ ఎగ్జాంపుల్ ఇప్పుడు సయనైడ్ అయాన్ ఇచ్చాడు అనుకోండి మీకు సిఎన్ మైనస్. సో హియర్ ఇక్కడ ట్రైవలెంట్ ఉన్నాయి. ఓకే, సో ట్రైవలెంట్ వాటికి ఉంటే మనం తీసుకోవడానికి లేదు ఇక్కడ. డైవలెంట్ అయితే జీరోగా కన్సిడర్ చేస్తాం, మోనోవలెంట్ అయితే నంబర్ ఆఫ్ మోనోవలెంట్ తీసుకుంటాం. మరి అలాంటప్పుడు ఎలా కనుక్కుంటాం ఇక్కడ హైబ్రిడైజేషన్ అంటే ఫస్ట్ మెథడ్ యూస్ చేసి. ఫస్ట్ మెథడ్ లో ఏంటి, నంబర్ ఆఫ్ సిగ్మా బాండ్స్ ప్లస్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ యూస్ చేసి కనుక్కోవాలి. అలా కనుక్కోవాలి అంటే యూ షుడ్ డ్రా ద లూయిస్ స్టార్ స్ట్రక్చర్. ఓకే, సో హియర్ వాట్ ఈస్ ద లూయిస్ స్టార్ స్ట్రక్చర్ ఫర్ సైనైడ్? కార్బన్ ఎన్ని ఉంది, వాలెన్సీ 4, నైట్రోజన్ 5, 5 plus 4, 9 plus 1, 10. So 10 electrons you can write like this. Okay, so here 10 electrons kada, carbon 4, nitrogen 5 plus this. So ila write anukondi 2 4 6 8 10. Okay, actually ga idi mamuli manam what can we predict? It has actually resonance structure. Okay, సో ఇది హైబ్రిడ్, రెజొనెన్స్ హైబ్రిడ్ స్ట్రక్చర్ ఇలా ఉండొచ్చు. సో అప్పుడు ఏమవుతుంది, టైప్ ఆఫ్ హైబ్రిడైజేషన్ ఆఫ్ కార్బన్ 1 sigma bond 1 lone pair means sp hybridization. Okay, 2 sigma bonds or 1 sigma bond 1 lone pair is equal to sp. So likewise you can predict. Okay, so this is regarding what is called hybridization. I think it is clear. So this is hybridization. One more important theory to explain the type of one more method is there, depending that is in the case of hydrocarbons. Okay, so depending upon the number of sigma bonds and pi bonds around the central atom, you can predict the type of hybridization. Okay, so for example, if what is called all 4 sigma bonds around carbon, all 4 sigma bonds around carbon, sp3 hybridization. Okay, so 3 sigma bonds plus 1 pi bond, 3 sigma bonds and 1 pi bond. Then the type of hybridization, 3 sigma bonds, remember not pi bond, 3 sigma bonds sp2 hybridization. Okay, 2 sigma bonds sp hybridization. So this is another method in the case of hydrocarbons. Okay, for example, if you are provided with this CH3, CH double bond, CH2, C1, CH. What is the type of hybridization of what is the type of hybridization of carbon? The second carbon, third carbon, fourth carbon and fifth carbon in the given compound. How can you predict it? So here coming to first carbon, total how many sigma bonds are there? 4, 3 CH, 1 CC. So that means it is sp3 hybridized. So here 2 sigma bonds and 1 pi bond. Okay, only 2 sigma bonds ఉంటాయి sp hybridization. Here 2 sigma bonds sp hybridization. Here all 4 sigma bonds sp3. Here around this carbon 2 sigma bonds only sp. On this only 2 sigma bonds. Okay, so that means is sp. So likewise you can predict all 4 sigma bonds around carbon sp3, 3 sigma bonds around carbon sp2. Okay, 3 sigma bonds వస్తాయి కదా ఇక్కడ 1 2 3 yes, it is sp2. Here 1 2 3 sp2. Here it is sp3. Here it is sp and sp. So likewise you can predict. Got it? So ఇదొక మెథడ్. ఇలాంటివే అడుగుతూ ఉంటారు చాలా. ఫర్ ఎగ్జాంపుల్ ఇఫ్ దిస్ ఇస్ ద గివెన్ క్వశ్చన్ గివెన్ CH triple bond CH. What is the type of hybridization of the first and second carbon in the given compound? Okay, so here you can write like this: H H H C H. Okay, triple bond CH. So maximum around carbon, how many bonds will be present? Sigma bonds, or by total number of bonds maximum must be 4 only. If all 4 are sigma bonds, sp3. If 3 are sigma bonds, sp2. If 2 are sigma bonds, sp. Okay, so here 3. No. ఏమవుతుంది ఇక్కడ? ఇది ఉండదు. 3 plus 1 4 అయినా sp. This is also sp. ఇది ఉండదు. 5 అవుతాయి అది ఉంటే. C triple bond CH. Okay, so likewise you can predict. ఒకవేళ ఇది ఇచ్చారు అనుకోండి. What is the type of hybridization of first and carbon atom in CH3COOH? So what is the type of hybridization of first and second carbon in CH3COOH? Actually it must be considered as first carbon. It must be considered as second carbon. If you write it's a structural formula, this would be the structural formula. C double bond OH. Okay, so now if you predict, so how many sigma bonds are there around carbon in this carbon? 1 2 3 sigma bonds. That's why it is sp2 hybridized. Here how many sigma bonds are there? 4. That's why it is sp3. Likewise you can predict for any given compound by using these 3 methods. Okay, based upon number of sigma bonds plus lone pair, then by calculating H or Q value, or by calculating number of sigma bonds present around the carbon atom in hydrocarbons, you can predict the type of hybridization. Okay, so the hybridization. So next, to overcome the drawbacks in hybridization, because hybridization is only what is called hypothetical. Okay, so to overcome this, another theory has been introduced, that is called as molecular orbital theory. Okay, so according to molecular orbital theory, here if you want to explain according to molecular orbital theory, if you want to explain the formation of a chemical bond, so then you can easily explain. How is? So actually according to molecular orbital theory, in the formation of a chemical bond, so the two atoms will approach together to form a bond. Okay, here again, according to your what is called valence bond theory or valence electron pair repulsion theory, or according to hybridization, only valence orbitals will participate in bonding. But according to molecular orbital theory, not only valence bond, even inner orbitals will also participate in bonding, thereby forming a special type of orbital called molecular orbital. Okay, oneness of one atom and oneness of another atom, they mix together, forming a new orbital called molecular orbital. 2s 2s 2p 2p. Likewise all orbitals, not only valence orbital, all atomic orbitals of two approaching bonding atoms, they mix together, forming a bond, forming a new orbital called molecular orbital. Okay, so here this mixing up of atomic orbitals of two bonding atoms, they will be in 2 ways. Okay, one, they mix with each other within the phase. Okay, and they mix with each other out of the phase. If these atomic orbitals mix with each other within the phase, that leads to the formation of bonding molecular orbital. Okay, they are called MOEDs, molecular bonding orbitals. Okay, if these atomic orbitals of two approaching atoms they mix out of the phase, okay, so then they lead to the formation of a special type of orbitals called anti-bonding orbitals. So generally bonding orbitals will have less energy, whereas anti-bonding orbitals will have more energy. That means when the two atoms approach together, always there is a possibility for two probability of undergoing mixing within the phase or out of the phase. If it will take place within the phase, that leads to the formation of bonding orbital. If the mixing will occur out of the phase, that lead to the formation of anti-bonding orbital. Okay. So actually, why this theory has been proposed is according to this molecular orbital theory. So your atomic orbitals have wave nature. So by considering the wave nature of the atomic orbital, for example, if this is the atomic orbital of one bonding atom and if this is the atomic orbital of another bonding atom, so they may mix with each other within the phase or out of the phase. If they mix within the phase means what? So one trough will mix with, will go and enter into the trough of another wave of the atomic atom, of atomic orbital of another atom. Okay, crust into crust, trough into trough. So in that way, if the mixing takes place within the phase, that is called as bonding orbital. So then you will get like this. Okay. So if this will enter into this and this will enter into this, so then you will get like this. So that means the magnitude, okay, of this trough or crest will increase. That lead to the formation of a bond. That's why that orbital, that new molecular orbital is called as bonding orbital. Okay. If they mix out of the phase means what? Into one trough, if one crest will enter, so then they will get cancelled. Okay. So here, what will happen? If this is one orbital, okay. If you consider this as another atomic orbital, so then it is in plus direction, this is in minus direction. So that's why their magnitude will get cancelled. Okay, so that doesn't lead to the formation of bond. This is called as anti-bonding orbital. Got it? So according to molecular orbital theory, all atomic orbitals of all bonding atoms will participate in bonding. Okay, these atomic orbitals undergo mixing either within the phase or out of the phase. Within the phase will mix, it leads to the formation of bond. That's why those orbitals are called bonding orbital, molecular orbital. If they mix out of the phase, that lead to the formation of anti-bonding orbital. These anti-bonding orbitals do not participate in bonding. Okay, so generally anti-bonding orbitals will have more energy and bonding orbitals will have less energy. So that's why they can be denoted as BMOs and ABMOs. BMO means bonding molecular orbital, ABMO means anti-bonding molecular orbital. Okay, so here, for example, if oneness of one atom and oneness of another atom they mix, so then there is a formation of, there is a possibility of forming two types of orbital. So that is BMO and ABMO. Okay, so BMO, if it forms sigma 1, it can be denoted as sigma 1s. Okay, if it doesn't form bonding as it is anti-bonding, it can be denoted as like this, sigma 1s star. So this sigma 1s star denotes anti-bonding 1s orbital, whereas sigma 1s denotes bonding molecular orbital. Okay. For example, 2s of 1, 2s of 2. Then you will get two orbital. BMO sigma 2s, ABMO 2 sigma s at 2 sigma s star. Okay. Likewise 2p. But p orbitals can participate even in pi bonding also. So if it participates in pi p without star, pi p with star. Pi p denotes bonding molecular orbital, whereas pi p with star denotes anti-bonding molecular orbital. Okay, so now these molecular orbitals they also will be filled with the electron as per the rules which govern the filling up of atomic orbitals with electrons. That is of Gauss principle, Hund's rule, etc. That means here also higher energy orbitals lower energy orbitals are first filled before filling up of higher energy orbitals. Okay, here also the pairing would occur. First, all molecular orbitals are filled with one electron. Okay, so then first we should write that what is the order of energy of molecular orbitals up to nitrogen, then after nitrogen. Okay, so when we know about this order, then we can write molecular orbital energy diagrams for any given molecule or ion. So by that you can predict bond order. Bond order is nothing but bonding electrons minus anti-bonding electrons by 2. Okay. So when you predict bond order, then by using that you can predict their bond parameters. That is bond length, bond energy, etc. Okay. So there is one small topic remaining in our chapter, that is energy order, then MOEDs for some molecules, then how to predict bond order for few ions or few molecules, because generally the questions would appear even on bond orders, okay, based upon this theory. So that's why that you should learn in detail. Okay, then dipole moment and hydrogen bonding. Okay, tomorrow mostly I'll complete this topic. So before that, first you go through theory part once through from your text or from your material or from your OP turned. Okay, then try to do the objective questions regarding hybridization, formal charges, etc. because that is also very important. Okay, by tomorrow we can put full stop because from Monday onwards we will go for new topic. Okay, thank you.
Good morning, everybody. We'll discuss some more questions on field potential energy. In this graph, along x-axis, distance is plotted along x-axis, and potential, electrostatic potential is plotted along y-axis, and distance, the x-coordinate in a three-dimensional space, the x-coordinate is plotted along x direction, and electrostatic potential is taken along y-axis. As the x-coordinate varies, the potential changes, the electrostatic potential changes due to some unknown charge distribution in a space or along x direction. As the coordinates change from x equal to 0 2 meters, 4 meters, so on, 6 meters. As the position coordinate is changing, the potential is varying continuously. Electrostatic potential changes like this. So now the question is, electrostatic potential due to a charge distribution is shown. Electrostatic potential due to a charge distribution varies with x coordinate. Electrostatic potential due to a charge distribution varies with the x coordinate as shown in the graph. Varies with x coordinate as shown in the graph. Draw the corresponding field versus x coordinate graph. Draw the corresponding EX graph. Draw the corresponding EX graph. From the shown graph, you have to draw the corresponding field versus x coordinate distance graph. So here the concept is E equal to or E bar equal to minus dV by dx, and electrostatic potential E is equal to Ex is minus dV by dx, and this field is in I cap direction, in x direction. Now, from the given graph, 0 to 2 meters, the potential increases, and you can calculate the slope, and 2 to 4 and 4 to 6, you can calculate the slope. And the slope of the graph can give you the electrostatic field. So you can calculate the electric field by calculating the slope. And after calculating the electric fields, then you can draw the graph. First, you are advised to calculate the electric field intensity between 0 to 2. Next, electric field intensity between 2 to 4 meters. Electric field intensity between 4 to 6 meters. The electrostatic field you are supposed to calculate between 0 to 2, 2 to 4, and 4 to 6. And already we discussed the conceptual part of it. That is, electric field is positive when slope is negative, and electric field is negative. Direction of electric field is negative when the slope is positive. So when this dV by dx slope is positive, field is negative. When the dV by dx slope is negative, the field direction will be positive. So you can obtain a positive value or negative value, or any value you can obtain. So either a positive or a negative value or a zero value you can obtain. After getting these fields, we can see about the drawing of field versus x, E versus x graph we shall draw. What is the value at x is equal to 2 and x equal to 4? This is you take it as a plus 10 volt, 0 to 4. This is plus 10 volt. Is the vision clear? Diagram, is it clear? Okay, the E 0 to 2 yeah, your answers are what you have given is E 0 to 2 5 volts, and electric field between volts 0 to 2 it is 5 Newton per coulomb or volt per meter. It is field is volt per meter. 0 to 2 you answered it as 5 volts, and E 4 to 6 you answered it as again 5 volts. So slight changes are there. This is correct. Yes, you have ignored negative sign just now. Now it is correct. Yes, the direction of field we have to mention, because while drawing the graph, we have to show the direction of field, positive or negative. -5. I'll see. So -5 correct. But which one is -5? Between -5 between 0 to 2. Okay. And 4 to 6. Between 4 to 6, also -5. Negative slope, no? Here, between 0 to 2 meters, if slope of VR graph between 0 to 2, if it is positive, slope is positive, then field will be negative. And between 2 to 4, 0 slope, and field is 0. And between 4 to 6, negative slope. Between 4 to 6, negative slope means field is positive. So you people have got the answers correctly. That is 0 to 2. The answer is the field is -5 volts. -5 in the sense negative direction. The field direction is negative. Since it is a one-dimensional field, I am not showing in vector representation. I am just giving the magnitude and direction separately. Next, between 2 to 4, electrostatic field is 0. And between 4 to 6, since we have negative slope, field is positive, so +5 volts will be the field between 4 to 6. This is the conclusion. Now you can tell, you can draw yourself the graph. You can draw field versus x, E versus x graph. You can draw. First, between 0 to x equal to 0 to x equal to 2 meters, the field will be negative. That is -5 volts. I can show in the fourth quadrant. I can show here. There is a -5 volt per meter. I am showing here -5 volt per meter. And between x is equal to 2 to 4, I am not showing any graph since field is 0. And 4 to 6, between x equal to 4 to 6, field is in the positive direction from here to here. So electric field is positive between 4 to 6, which is again here +5 volt per meter and here -5 volt per meter. This is the graph of field versus distance graph, field versus displacement graph, or field versus distance along x direction. And now you can ask for any clarification regarding the graph and all. And the signs, negative signs and all, if it is clear, we shall proceed to the next question. Yes, all of you, is it clear? Concept is there is a concept underlying the question. The drawing the graph is quite easy if you know the technique. If you know the concept, easily you can draw the graph. You can convert the given potential Vx graph. You can convert it into field versus Ex graph. Vx to Ex graph you can convert. We'll take up the next question. I hope it's clear to everyone. Next question. Write down. Next question. diagram related to the next question. These are the three charged particles placed here. Plus Q is a charge, and here minus Q, second charge, and third charge again minus Q. Three charges are placed across the vertices of the triangle, and the side is 10 centimeters is the side of the equilateral triangle, and across the vertices three charged particles are placed. The question is find the electric potential. Find the electric potential. You have to calculate the electric potential at a point P. Electric potential at a point P, where the point P is here. Electric potential at a point P. This point P is the midpoint of the base. P is the midpoint of the base. And one more information is this a magnitude of Q. Each charge Q, it is having a magnitude of 5 microcoulomb. The charge Q is 5 microcoulomb, means magnitude of charge is 5 microcoulomb. That implies here minus 5 microcoulomb, minus 5 microcoulomb, and plus 5 microcoulomb. And each side is of 10 centimeters, equilateral triangle. You have to calculate the electric potential at point P. Where is the point P? It is 5 centimeters away from minus Q and 5 centimeters away from minus Q. This P is the midpoint of the base. Now, I hope you can start calculating. So, you can make use of the electrostatic potential at a point P is the scalar sum of electrostatic potentials. And the electrostatic potential is 1 by 4 pi epsilon naught Q by R. You can calculate the net electric potential at a point. Any answers? The answer which you have sent is K of minus 2 plus 1 by root 3 into 10 power minus 4. It's okay, but k value is 9 into 10 power 9. We require 3 root 3 . So due to two charges, this minus q and minus q, due to both of these charges, the electric potential is minus kq by r, where r is 5 centimeters. So that is minus kq by 5 centimeters minus kq by 5. You can add the two potentials, that is minus 2 kq by 5 centimeters plus the top charge potential, electrostatic potential due to the topmost charge, that is plus kq by r, where this distance has been calculated. This distance I'm getting it as 5 root 3. Now finally, kq by 5 if you take common, kq by 5 into 10 power minus 2 if you take common, say 1 by root 3 positive minus so if you calculate kq by 5 into 10 power minus 2, I have taken common, then I'm getting positive 1 by root 3 minus 2. So that is 9 into 10 power 9 into charge 5 into 10 power minus 6 by 5 into 10 power minus 2 into 1 by root 3 minus 2. 1 by root 3 minus 2 in the sense 1 by 1.732, 1 by 1.732 minus 2. And so finally, this final numerical value, if you can calculate, you can give the final value if it is possible. And definitely, final electrostatic potential, you will definitely get a negative value only, no doubt about it. Or else, I can give you the final calculated value in order to save the time. You can anyway calculate it. 3 root 3 minus 18 into 10 power. So the final calculation is for the net potential it is minus 1.28 into 10 power 4 volt is the final calculation, minus 1.28 into 10 power 4 volt. Next question. Yeah, correct, ma. 12 point, you can get like that also. Minus 12.81 into 10 power 5. Okay. Correct answer. You have got the correct answers. But what I have done is I have substituted that all root 3s and k value, all the values I have substituted. Final calculation I am giving you. That's it. If you substitute those values, you will get correct. You will get this answer, minus 1.28 into 10 power. Next question. Next one. This is a charge 1 and it is separated by a distance with another charge. So here the charges are given plus q and plus q. Two charges of same sign and same magnitude plus q and plus q. They are separated by a distance d. D is a separation between these two charges. Now, the question is two charges each of a magnitude q. Two charges each of magnitude q of same sign, magnitude q of same sign, are released when they are at a separation d. Are released when they are at a separation d. Are released when they are at a separation small d. Find the velocity of each sphere. Find the velocity of each sphere. I mean to say, find the velocity of each charge when their separation is 2D. When their separation is 2D. Find the velocity of each sphere when their separation is 2D. The velocity of each sphere, of course, we are trying to calculate the magnitude of velocity. The direction of velocity, obviously, this right side charge has a direction of velocity this way, and this left side charge, this charge will have a velocity direction towards negative x. This is having a velocity in the positive x direction. This one negative x direction. And you know very well, I need not tell why they move, why these charges are moving away. You know very well. But here the issue is okay, how to calculate? How are we going to calculate the speeds right now? Direction I know, but the speeds of the charged particles, how can we calculate? What is the process or what is the concept we can use? By using which concept we can calculate the speed of each particle, sir? The two particles, they are released from some initial separation. From certain initial separation, they have been released. And as they are let free, as they are constrained to move in single direction, one direction, that is along x direction, they are constrained to move. They can't, they are restricted to move in other directions. We are considering purely one-dimensional motion. Now, why these two charged particles are moving away? Because of the electrostatic repulsive force, and assuming no other force, assuming there is no other force except the electrostatic repulsive force. That is the assumption. So under that assumption, these two charged particles will start moving like this. They are separated away. Now, when the separation becomes 2D, what is the speed they might have gained because of the electrostatic repulsive force? So there is some force acting on this. There is some force acting on this. Because of this force, these charged particles move this way, and they are gaining speed. They are gaining speed. What might be the speed when the separation between them has reached to 2D? So how to calculate? Any idea? What is the process of calculation? In before problem, can't we use E is equal to F by Q? See, in the before problem means I hope in the before problem means what? That triangle problem only, no? Before problem means in which problem you are speaking? Triangle problem only, no? In triangle problem, if E is equal to F by Q, if you want to use, but we don't want field, no? We require potential at P, at point P. To it's a long process, no? But even though E is equal to F by Q, directly if we have a facility to calculate the potential, why to go for a very lengthy method? And that too, here a lot of constraints are there using E is equal to F by Q. Force you may calculate, but you will get the magnitude of force. You will get the magnitude of force. You won't get at point P, the related information you won't get. You will only, by using F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, by using the concept, you may get the force acting on any one charge that you may get. So, and what you have to substitute in place of F that you think. And one thing you can do, as you asked, one thing I can suggest, at P point you can find field, and you can relate with potential, but that is a lengthy process. There is a relation between field and potential. Field E is equal to minus dV by dr. F is equal to dP by dt means that is momentum. dP by dt, dP bar by dt, that P stands for momentum, not potential. So momentum, here the particles are at rest. Though forces are acting, the three particles of the triangular configuration, they don't move. Anything else you would like to ask? Yeah, I have to appreciate you for asking questions. Always, I prefer you people clearing your doubts and asking questions. Always, I will be preferring that only. And Masa, yeah, I'll give. Yeah, thank you for asking doubts, sir. Yeah, here, anybody, first you tell method, no need of the final answer. At least you just give me the idea how we are going to proceed. Suppose I'm showing you the 2D separation. Let me show. This is the final position. This is the final position. And this is 2D. Here the speeds we are supposed to calculate. Here the speeds we have to calculate. The speed of particle in this final position. Yeah, anybody? What is the process of calculation? Distance moved by each mass is d by 2. Are you sure about it? How come? Distance moved by each mass is d by 2. But here we are supposed to calculate the velocity. You may predict distance, but you can't calculate velocity like that. Why? Because velocity is displacement by time, or v is equal to u plus at. You can't use those two equations. You can't use. Why? Because this motion of charged particle, the motion of charged particle is not uniform velocity. It doesn't come under uniform acceleration or uniform deceleration. So electrostatic force is a variable force, and the acceleration of the particles are also variable. So it is a variable acceleration, the variable motion. It is neither constant acceleration nor constant velocity. You can't use v equal to u plus at. You cannot use velocity displacement by time like that. Why? Because the reason is electrostatic force is 1 by 4 pi epsilon naught Q1 Q2 by R square. Force is a function of radial distance separation. Separation is a variable. R is a variable, so force depends on R. Next, acceleration is force by mass. So Q1 Q2 by 4 pi epsilon naught R square. Acceleration is a force by mass. So again, acceleration is a function of R. A is proportional to 1 by R square. That means acceleration is also a variable. For constant acceleration only, you can use v equal to u plus at and all. And for uniform velocity, you can use velocity equal to displacement by time. So you cannot go with velocity displacement by time, and equations of motion you cannot use. Since it is a variable acceleration, and acceleration varies with r square. It changes with r square. So the next option is integration, but that is lengthy. To avoid that lengthy process, we go by energy conservation. So Under what cases you can conserve energy? What is the condition for conserving mechanical energy? When can we conserve mechanical energy? So the condition is we can conserve mechanical energy when, as long as only conservative forces do work on the particles, as long as conservative forces do work on the charged particles, conservative forces alone do work, then you can conserve mechanical energy. If at all external forces or frictional forces, if they participate, then you are not supposed to conserve mechanical energy. So here, definitely between the two charged particles initially when they start moving, the only force between them is electrostatic force. So you can conserve energy. Why? Because the electrostatic force is a conservative force. You can conserve mechanical energy between initial position and final position. When they are separated by D, when the separation is D, initial energy, E initial. When the separation is 2D, let the energy be E final. So conserving mechanical energy, E initial equal to E final. Total mechanical energy initial is equal to total mechanical energy final. Initial energy is between these two charges when they are initially separated by a distance D. The initial energy is potential energy, electrostatic potential energy, that is 1 by 4 pi epsilon naught Q1 Q2 by R. 1 by 4 pi epsilon naught Q1 Q2 by R, electrostatic potential energy, and plus kinetic energy 0. Initially they start from rest. Next final, when they are crossing a separation, when they are reaching the separation 2D, the potential energy is K Q1 Q2 by R plus kinetic energy of first particle plus kinetic energy of second particle. Since masses are same, the speeds I'm writing it as V and V. Since same masses and same electrostatic force act on two particles, magnitude of electrostatic force is same, and same masses of the two particles are same. What are you supposed to find out now? You are supposed to calculate the speed of the charged particle V. You have to calculate. So this is the equation. What is this equation? Initial mechanical energy is equal to final mechanical energy. Initial means at a separation D, when the particles are separated by a distance D. Final energy we have written when the two particles are having a separation equal to 2D. So the answer is V equal to under root of yeah, you can give your answers. Can you send it once, sir? Yeah, you can give your answers. V is equal to under root of kq square by 2md. It is correct answer. Kq square by 2md is the correct answer. I am writing, I have substituted k value. You have got the answer as you are giving the answer as kq square by 2md, like this you have given. So what I have done is under root of q square by 2 into 4 pi epsilon naught into md. So the speed of the each charger have a speed, it acquires a speed of q by 2 into under root of or q into q by under root of 8 pi epsilon naught m into d. You can simplify, and finally you can give it as a q by 2 into under root of 2 pi epsilon naught md, like that also you can do. So the final answer is kq under root of kq square by 2 into m into d, or q by under root of 8 pi epsilon naught md, the speed of each charger particle when they have a separation 2d. Next question. Next question. Next one. In this question, we have an inclined plane. There is a fixed horizontal inclined plane, and a charged particle has been placed here. This is a charged particle. This charged particle has a mass m and a charge q, positive charge, and acceleration due to gravity is given as g in the downward direction, and the electrostatic field is switched on in this direction. This is the direction of a uniform electric field in that region. It is horizontal. It is parallel to the ground. It is horizontal. M is a mass. Small q is the charge of the block. It has been placed on the inclined plane. This is the diagram. Now, what you are supposed to calculate is what are you supposed to calculate is find the coefficient of friction. Find the coefficient of friction. Needed. Find the coefficient of friction needed between block and inclined plane. Find the coefficient of friction needed between the block and inclined plane for the block to remain at rest. Find the coefficient of friction needed between block and the inclined plane so that the block remain at rest. So that the block remain at rest with respect to inclined plane. So that the block is at rest with respect to the inclined plane, or on the inclined plane, the block has to be at rest. So for equilibrium, that means indirectly the charged particle to be in equilibrium on the inclined plane, what should be the minimum coefficient of friction needed, how much coefficient of friction is required, and assuming that when there is no electric field, the block may move down, it may slide down, such that under the absence of electric field, when E bar is equal to 0, mg sin theta is definitely greater than limiting friction. This is the condition. When the field has been switched on, it has reached to an equilibrium condition. When there is no field, there is no force on the block, charged block. When there is no force, the only forces left over are mg sin theta in the downward direction and frictional force, limiting friction in the upward direction. Here, this is a rough surface, coefficient of friction is mu. So when there is no electric field, the block might slide in the downward direction. Now, what is the role of electrostatic field? It should exert force on the block in such a way that it should stop or it should prevent the block from sliding down. The force exerted by electrostatic field on the charged block is going to prevent the block from sliding down the incline. So now you think about it. Of course, I don't say it is a very easy, that I can't say. Equations you have to go by free body diagram and you have to solve. You have to solve for coefficient of friction. Mg by Eq plus Mg tan theta. Let me check. Mg by Eq plus Mg. Mg tan theta. No. No. It's not Mg by Eq tan theta. Are you doing any? Have you done any trigonometric transformation? I have. My answer is my required answer is no. My required answer is without doing any trigonometric calculations, directly as it is calculating for you. No need of any simplification using trigonometric transformation. Directly, if it is sine, you keep it as sine theta. If it is cos, you keep it as cos theta, and give the answer. Assume that in the options are in terms of sine theta and cos theta. Assume the 4 options are in terms of sine and cos, and the answers are not there in tan theta. Then what is your answer? Mg sine theta by Mg cos theta plus Eq. No. Yeah, what is the other answer? Mg sine theta minus Eq cos theta by Mg cos theta plus Eq sin theta. Fantastic. Good. Mg sin theta minus Eq cos theta by Mg cos theta plus Eq sin theta. Very good. Okay. Done. This is the charged block, and I'm trying to draw the free body diagram. Say here, the component of electric force EQ is the electrostatic force. Its component is EQ cos theta is the component of electrostatic force, and the other forces which participate here are Mg sin theta, and normal reaction is N, Mg cos theta, and one more component is for EQ cos theta and EQ sin theta. These are the components of electric force. EQ has 2 components, EQ cos theta and EQ sin theta. Next, by doing the equilibrium along the perpendicular of inclined plane, along the normal of inclined plane, if you write the condition for equilibrium, then N is equal to Mg cos theta plus EQ sin theta will be the normal reaction when we write the condition for equilibrium along the normal direction, along the perpendicular of inclined plane. N is equal to Mg cos theta plus Q sin theta. Next, the other equation is for equilibrium. The block should not move down the incline or up the incline. Block should not move. That means we have to take the condition for equilibrium even along the inclined plane. Also, we have to take the condition for equilibrium. The equilibrium condition is Mg sin theta. The force down the inclined plane Mg sin theta is equal to the force up the inclined plane. What are the forces of the inclined plane? Frictional force mu n and EQ cos theta. This electric force, as I discussed in the beginning of the problem, this electrostatic force should prevent the block from sliding down. Means what? If this electric force is a force which acts on the charged body, in such a way that if it prevents the block from sliding down, means the block tries to slide down and it has to prevent, then the frictional force it will be up the inclined plane. So mg sin theta is equal to eq cos theta plus mu n, mu into normal reaction. Mg sin theta is equal to eq cos theta plus mu into normal reaction. Now this normal mu we require. So what you are supposed to write here, mu n is equal to mg sin theta minus eq. Mu n is mg sin theta minus eq. Next, mu is equal to mg sin theta minus eq by normal reaction. That is mu is equal to mg sin theta minus eq by normal reaction is mg cos theta mg sin theta minus eq cos theta by mg cos theta plus eq sin theta. The coefficient of friction is mu is equal to mg sin theta minus eq cos theta by mg cos theta plus eq sin theta. Coefficient of friction required. Okay, ma'am. So here is all of you. Let me give you a brief review. Here, electric field will exert a force, that is EQ. This is the direction in which electric field will exert a force. And frictional force will act like here. And this is electric field EQ. And this is the angle. This angle is theta is the angle made. If this is theta, then EQ cos theta will be up the incline. EQ sin theta will be perpendicular to the incline. So two components of EQ. EQ is EQ cos theta and EQ sin theta. Next, other components or other forces are normal reaction opposite to this, and mg sin theta down the inclined plane. These are the other forces. Mg cos theta is perpendicular to the inclined plane. So the mg cos theta plus EQ sin theta is giving a normal reaction. Equate both of them, and now the other forces are here. Frictional force upward up the inclined plane. EQ cos theta up the inclined plane. Add them. Mu n plus EQ cos theta is equal to downward force mg sin theta. So mg sin theta equal to mu n plus EQ cos theta. Mg sin theta is equal to mu n plus EQ cos theta. This is one equation for the equilibrium condition when we write equilibrium along the inclined plane. And perpendicular to the inclined plane, if you write the equilibrium, n is equal to mg cos theta plus EQ sin theta. Normal reaction is balanced, and two equations, and we can solve in this equation 1 and this normal reaction equation 2. Let us consider this first equation. If you substitute n value, that is enough, and you can calculate, or else you can separate mu n from first equation, and you can calculate mu by substituting n value. Normal reaction value you can substitute by writing the equation for mu. So I hope this free body diagram is clear. And if you require any clarifications, please ask. Regarding this question, any doubts you have, you can ask for any clarification anywhere. It may be why we have taken these forces and about the components and about the calculations. Anything, if you would like to ask, you can ask quickly. Next question. Next question. Shall we proceed to the next question? Shall we discuss the next question? I'm considering two plates, a positively charged plate down and upward plate a negatively charged plate, and these two plates are having a separation of small d. Small d is the separation between these two plates, positively charged plate and negatively charged plate, and in between here, a negatively charged particle is projected from the lower plate. A minus q charge is projected with the initial velocity u, and the angle of projection is 45 degrees. Is the angle of projection, and u bar is the initial velocity vector, and it is being projected in between two plates. So, what is that much big thing in projecting this charged particle? Means ignoring gravity or consider the effect. Don't consider the effect of gravity or ignore gravitational force acting on the charged particle. Consider only electrostatic force. That is the first thing. Next, G equal to 0. That doesn't mean that G is absent, but considering the ignoring the effect of acceleration due to gravity, you have to calculate the things. Now the question is, this is the given diagram. A negatively charged particle is projected from one plate, and here what you can expect, there is a field from downward plate to upward plate. There is a electrostatic field. In this vertical field, this charged particle is projected from here. Like this, the charge has been projected at an angle of 45 degrees. This is one plate and this is the other plate. This is a positive plate and this is negative plate. D is the separation. Now the question is, find the maximum value of projection velocity. Find the maximum value of projection velocity of the negatively charged particle. Find the maximum value of projection velocity of the negatively charged particle such that it should not hit the upper plate. You should throw it maximum speed. You should project with maximum speed, but still it should not hit the upper plate. Means what? It should go very closer, like this. It should go very close within this plate. It should not touch, means it should just pass from the top surface. This is the plate, and the charged particle's path should be like this. It should not hit the plate exactly. It should just cross, or it should be passing very much nearer to the upper plate, and then it should go down. But one thing, why this charged particle will have the path shown? Why it will move in this way? What is the exact path? How can we describe the path of the particle? On what basis? So here, on the charged particle, we have u cos theta, one component of velocity, and one component is u sin theta. Next, one more is electrostatic force and electrostatic acceleration. The acceleration given by electrostatic force, that is in the downward direction. This is a negatively charged particle, so it is EQ by m will be the acceleration in the downward direction, acceleration downward, and the charged particle is projected. Instead of gravity here, EQ by m, this is same as that of a projectile motion, oblique projectile. It behaves as if a oblique projectile. Instead of gravity, we have EQ by m. Why EQ by m downward only? Because it is a negatively charged particle. For field is upward, charge is negative. So if there is a negatively charged particle, then always field will exert a force on the negative charge opposite to the direction of field. The negatively charged particle experiences a force, electrostatic force, opposite to the direction of electric field. So therefore, acceleration will also be in the opposite to the direction of electric field. F is equal to ma. Now, what you have to calculate? The maximum speed with which, or the maximum projection velocity, you have to calculate. The angle of projection is 45 degrees. Some more values are also there. That is, mass of the charge is 1.6 into mass of the charge is 1.6 into 10 power minus 30 kg, and magnitude of negative charge is minus 1.6 into 10 power minus 19 coulomb. The charge of this particle is same as that of electron charge. Mass is given as 1.6 into 10 power minus 30. Charge of this negatively charged particle is minus 1.6 into 10 power minus 19 coulomb. These are the values. Two into under root of e cubed. Oh, without numericals you have given. Under root of e 2 under root of e q d by m. Value of EF. The magnitude of electric field is E bar is equal to 10 power 3 volt per meter. Magnitude of electric field in the upward direction. Field will obviously be in the upward direction from lower plate to upper plate. From lower plate to upper plate, the electric field is. So field is a 10 cube, 1000 volt per meter. Maximum height attained is u square sin square theta by 2 into eq by m. I'll recollect you the maximum height formula u square sin square theta by 2g. In place of g, we have eq by m all of it. Why? Because in place of gravity here, in the downward direction, eq by m is acting. We have replaced gravity with eq by m. And maximum height is u square sin square theta by 2 into eq by m. So maximum height, how much? 2 centimeters it has to cross. So maximum height is 2 centimeters. And u square you have to find. You have to find out u square. Then you have to calculate. 2 eq h maximum. 2 eq h maximum equal to m into u square sin square theta. And u square value you have to calculate. So how I have written this is 2 eq h maximum, e value 10 power 3, charge given. Maximum height is nothing but the separation between two plates. The separation between two plates, this h maximum is this one is d, that is 2 centimeters. Mass of the charged particle is given. This u square by 2 is because of the angle of projection 45 degrees. Sin square 45 is 1 by 2. That u square by 2 I have retained here. Remaining in mass I have sent to the other side. So you can calculate for u square. U square value you can calculate. 4 into field 10 power 3 into charge 1.6. Magnitude of charge is sufficient. 1.6 into 10 power minus 19 into 2 centimeters. 2 into 10 power minus 2 by mass of the charged particle is 1.6 into 10 power minus 30. And definitely you won't have a difficult calculation. 1.6 will go away. Remaining thing are same. In terms of root 2, you can give the answer. In terms of root 2 into something, you can give the answer. So 2 into 10 power 7 into root d. That means 2 root 2 into 10 power 7. 2 into 10 power 4 root d. 2 root 2 into 10 power 4. One more answer is 2 root 2 into 10 power 6. This is correct answer. 2 root 2 into 10 power 6 you will get. 2 root 2 into 10 power 6 can be the answer. After calculation, you will get the answer as 2 root 2 into 10 power 6. Obviously, if you remove the square, you will get a under root. So inside the root we have 8. So inside the square root 8 means 2 root 2 into something you will get. So 2 root 2 into that something is 10 power 6. All of you check once. It should be exactly 2 root 2 into 10 power 6 meter per second only. Substituting this d value, I have substituted as 2 centimeters, that is 2 into 10 power minus 2. You can just check once the calculation and confirm the answer. Yeah, okay. Take down the information of the question once again. A negatively charged particle of mass m value already I have given. A negatively charged particle of mass m is projected with the initial speed u. A negatively charged particle of mass m is projected with the initial speed u at an angle 45 degrees. With an initial speed u at an angle 45 degrees. With the positive plate. The plates are sufficiently long. Find the maximum value of projection velocity. Find the maximum value of projection velocity. Find the maximum value of projection velocity of the negatively charged particle. Find the maximum value of projection velocity of negatively charged particle so as to not to hit the upper plate. Means what you have to find out? Find the maximum value of projection velocity so as to not to hit the upper plate. So this is the complete information regarding the question. Is it okay? Is the information sufficient? Yeah, you can confirm the final answer, all of you. Let them. Yeah, it seems I hope everybody you have calculated and you have got the answer as 2 root 2 into 10 power 6 meter per second. Next question. 2 point charges Q1 and Q2 are placed. 2 point charges Q1 and Q2 are placed. 2 point charges Q1 and Q2 are placed at 0, comma 1, placed at 0, comma 1 and 1, comma 0. Two point charges Q1 and Q2 are placed at 0, comma 1 and 1, comma 0. If Q2 is equal to Q1 by 2, if Q2 equal to Q1 by 2, then if Q2 is equal to Q1 by 2, then electric field vector at P, if Q2 is equal to Q1 by 2, then electric field vector at P, makes an angle theta. Then electric field vector at P makes an angle theta with the x direction. Electric field vector, the net electric field vector at P make an angle theta with the x direction. Then find the angle theta. You have to find out the angle theta. Means one charge is placed at 0, comma 1, Q1. This Q1 is one charge. Next, other charge is placed at 1, comma 0, that is Q2. And the relation between Q1 and Q2 is Q2 equal to Q1 by 2 is the relation between two charges. Next, due to Q1 and Q2, there will be some field, net field. Due to Q1 and Q2, at P point, that is at 1, comma 1, there will be a net field. This net resultant field makes an angle theta with the x direction. What is the angle made by the net field with x direction? This net field, what angle it makes with the x direction? That is the question. So here, at a point P, which is having a coordinate 1, comma 1, the net field is due to the two positive charges, due to charge Q2 and due to the charge Q1. Two field components you have. This Q1 charge has a field E1 and Q2 charge it has a field E2. Where E1 is 1 by 4 pi epsilon naught Q1 by R square and E2 is 1 by 4 pi epsilon naught Q2 by R square. So you have E1 and E2. Now the net field will be making an angle theta with the x direction. This angle theta you can find out. So how to find this angle theta? That is just you can calculate it like this. Tan theta is the ratio of two field components tan theta. That is kq2 by r square by kq1 by r square. So tan theta, if you calculate k into q2 by 1 square by k into q1 by 1 square. So tan theta value you will get it as q2 by q1. Tan theta is equal to q2 by q1. So the angle made by the net field with the x direction you can calculate. That is tan inverse of something. So theta is a tan inverse of 1 by 2 or 2. Is it tan inverse of 1 by 2 or 2? It should be, yeah, tan inverse of 1 by 2. Theta is equal to, yes, correct answer. Theta is equal to tan inverse of 1 by 2. Okay, we'll continue in the next class. We'll take up Gauss law applications, Gauss law and its applications in the next class. The Gauss law and its based problems, applications tomorrow we shall see. So we'll continue in the tomorrow's class with the concept of the formulae and concept of Gauss law, and based upon Gauss law, some problems we shall discuss. Yes, sir. Completed.
Students, please save this as this screenshot. I will be discussing. You will be getting 4 sheets like this. I can't dictate and make you write. So what is the idea is, you will get these 4 sheets. Each point elaboratively I will explain. Take the screenshot of the 4 sheets which you are getting now. This is the first sheet. Okay, if you are done, we will present you the second sheet now. Yeah, we'll go to the second sheet. This is the second sheet. Now you will be getting the third sheet now. This is the third sheet. Yeah, fourth sheet. This is the last sheet. Okay. Now, I will start by explaining the concepts. Yes. Now, first and foremost, we are embarking upon the topic known as the set theory. Set theory has as itself one question being asked, and other than that, it has profound applications in probability also. So subsequently, in the next week, we are taking up the probability and probability in an axiomatic approach. In an axiomatic approach, the probability, we will be talking about the set theory will be involved now. So what we do now, set theory parts we will see. See the first part here, the first point. What is the definition of a set is being exposed. Now in the concepts and the theory, check the first sheet. First is concepts and definitions. first point. The first point is giving you the definition of set. Set is a collection of objects. It is any collection need not give you set. Set is a collection of objects. What type of objects is it? It is a well-defined object. What is a well-defined object? What is a well-defined object? The well-defined object is the object which, when given a collection, you can say that given an object, you can say to which collection it belongs. For example, if I say AEIOU, you can say that these are the collection of objects of what? Objects of from English alphabet. If I say apple, you will able to say it is a element or it is an object which is collected from the set of collection of fruits. Now, this is a well-defined. What is a well-defined? When you are given with one object of the collection, you should able to tell to which collection it belongs. Clearly, you should say. For example, I will say the number of students who are wearing high heel. The high heel is a relative term. And the relative terms are not considered as good collection. Intelligence. So intelligence is also is a relatively measured. Such relative measure height. The students with larger height. What is the exact height, base height? We don't know. Such collections are not considered as well defined, and the collection of such objects will not be constituted as what? Constituted as the set. So set means collection of well-defined objects. The objects which are collected are known as the elements. Then the way of representing the sets. There are popularly two ways of expressing the elements of sets. What are the two ways of expressing the objects of a set? A representation of the sets are, first one is known as the roster form. So what is a roster form? This is a roster form. Roster form or list form. In this, what they do, they use the flower brackets, and between the flower brackets, what they do, they will list the elements A, B, C, D, E, like that. They will list the elements. The elements are listed in within the what? Within the flower brackets, and they are separated by commas. This is a roster form or the list form. This is one way of representing the sets. Now, next form is what? The set builder form. Set builder form. Set builder form. So, what is a set builder form? In this, the elements are not listed. They use either slash or the semicolon. Colon they will use. X such that X is an even integer. So this is there in this method, the set builder form, the elements of the sets are described for their property. They will describe the property of the sets, set elements. How the elements are collected, they will describe. One more example is X such that X belongs to N and X less than or equal to 7. So then naturally, this from one form of the set builder to roster, we can convert 1, 2, 3, 4, 5, 6, 7. Whereas here, the elements are listed and separated by comma, whereas here, they are simply, described. These are the representation of the sets. And most number of times what happens, these sets are denoted by the capitals. The capital English alphabet are used for sets. Okay. Now, next what happens? After this one, the number of elements of a set. The set consists of objects. No? Those objects are called what? Elements. The number of elements of a set is known as the cardinal number. They call it as cardinal number. And notation is of A. So n of A is said to be, n of A will give you what? The cardinal number. Cardinal number means the number of elements of the set A. Now, if the number of elements are finite, the cardinal number will come out as finite. If it is infinity, the cardinal number is infinity. Of course, the number of elements may be finite or infinite. Depending upon the number of elements finite, it is known as finite set. The finite set example, the number of students who are appearing for Bitsat, that is a finite set. And infinite set, natural numbers or whole numbers or integers, these are the examples for the infinite number of sets. Then the two sets are related like this. A set A has some elements. Every element of A is also present in B. The best example is A is students who is studying class 12, and the B is the set of students from age group of 15 to 19. Set of students from 15 to 19. The students who are studying 12 in our state or in our country, all will be between 15 to 19. Each person, generally, each person will be contained by that set. Okay. Now, in other words, the set of the people living in Hyderabad. Collection of the people living in Hyderabad. Then people who live in Telangana state. So every person who is living in Hyderabad also belongs to the set of where he is living in the Telangana state. So the every element of set A is also an element of set B. Then such set A is said to be subset of B, whereas B is said to be the superset. Now the symbol for subset. What is the symbol for subset? The slanted U. This is U. This is subset only. This is subset symbol. This is subset and contained by. Now next, naturally, every set has all the elements belonging to itself, and also the null set. Null set is also contains no element. Null set contains no element. No element is present in every set. So null set is subset of every set, and every set is subset to itself. So any set will have two subsets, null set and set itself. So they are called improper subsets. They are called what? Improper subsets. Every set is subset to itself, and null set is subset to itself. So null set, and A are known as improper subsets. Other than this null set and A, the remaining subsets are known as proper subsets. The total, if proper or improper, is nothing but 2 power n. How you will get 2 power n? So how the number of subsets of a set containing n elements? Null set is selecting 0 element. So selecting one element subsets are NC1, 2 element subsets are NC2, 3 element subsets are NC3, n element subsets are NCn. So when you add all of them, you will get 2 power n subsets. What are these 2 power n subsets? Including proper and improper. From that improper you take away, you will get a proper. So 2 power n minus 2 are the proper subsets. 2 power n are the total number of subsets. This is important. 2 power n subsets will exist. Now you can have a set whose elements are the subsets of set A. Okay, I will repeat this. Now you said that A is a set and n of A is the cardinal number of A. The cardinal number of A is the number of elements of A. Then you said I am having 2 power n of A. 2 power n of A is what? The cardinal number. 2 power cardinal number of subsets. You constitute a set whose elements are these subsets. So what is the cardinal number of this set? 2 power n of A. This set contains all the subsets of A. Such a set is said to be power set of A. That is known as power set. Power set, the definition is nothing but the set which is the set which is what? Containing the elements which are subsets of the given set. That is known as what? The power set. Okay. Next concept is, the next concept is equality of the two sets. Two sets are to be equal, A and B, if they satisfy two conditions. The first condition is the number of elements, the cardinal number should match. Then the second condition is the elements are to be identical, the same elements. They should have same elements and same cardinal number. Then such sets are said to be equal sets. Now next we will explore what we call the operations upon the sets. These are very much familiar to you. It is only a refreshing the concepts. A is a set and B is a set. Then collect the elements belonging to either A or B. So a new set formed by what? The elements collected from belonging to either A or B or both is known as what it is called. It is known as the union of the two sets. The new set formed by collecting the elements which belong to either A or B or both. The elements should belong to either A or B or both. Then such a new set so constituted is called union. A union B. So A union B is in a set builder form X such that X belongs to A or X belongs to B. This is the union. Now next a new set formed by collecting the common elements of A and B. A will have some elements, B will have some elements. The elements which are common to both can be collected. The set collected with set formed with the common elements of A and B is known as intersection. That operation upon the sets is intersection. X does that. X belongs to A and X belongs to B. Then there is a operation, the difference. What is the difference? The difference is the set containing the elements which present in A alone, exclusively A. Say for example, in your class, there are the students who are bringing pen and who are bringing pencil. This is a pen, this is a pencil. So you will collect the boys or girls who are having only pencil, only pen, both. You are collecting boys or girls who brought pen and pencil both. That will become intersection. Only pen but not only pencil but not pen. So A minus B is the set of elements which belongs to A but not to B. So X belongs to A and X does not belongs to B. Similar to that, B minus A. So B minus A is what? X belongs to B and X does not belongs to A. This is the one. Now next, A minus B and B minus A are the two sets. For them, you can operate a union. Such a operation is known as symmetric difference. This is known as symmetric difference. Such a symmetric difference is found. First, you have to find out A minus B, elements belonging to A but not B, elements belonging to B but not A, and collect the elements, that is A delta B are symmetric difference. Next, there is a concept of universal set. There is a concept of universal set. So what is a universal set? Every set which we are considering under is contained by one set. Whatever the set you are considering in your operations is already contained by a set. Such set is said to be universal set. For example, I am taking the number of students who are appearing for JEE Main in India. So those people are contained by the citizens of India, no? And such citizens of India are contained by citizens of the world citizens. So whatever the set you are considering, so the concept is any set which is under consideration is contained by another set, another superior set, another set. Such a set is said to be, which contains the set under study, is said to be universal set. Such a universal set is denoted by mu. Okay, so every set under consideration is contained by another set. Such a set which contains all the sets is known as universal set mu. Now next what happens? Here, next, yes. Next we will explore mu minus A. We have discussed A minus B. A minus B is nothing but X belongs to mu and X does not belongs to B. That is A minus B. X belongs to mu and X does not belongs to A. Such thing is known as the complement of the set A. The complement of the set A. So these are the operations on A. Next, we will explore what we call the Venn diagrams. Venn diagrams are the representation. What representation? The graphical representation of diagrammatic representation, rather the diagrammatic representation of the sets. Actually, initially they started with drawing a triangle, but later they discovered that it is easier to draw a circle. So in some books or in some diagrams, if you are finding triangles, don't get confused. Triangles are the circles. Yes, here these are the two circles. I am talking about this one. So they are contained by another set. Such set is a universal set. That universal set is drawn as a rectangle. This is mu. Now this is A, this is B. Use any strokes, whether they are vertical, horizontal, or slanting. But distinction of the usage of the strokes is taken care of. If you are using the horizontal for A, don't use horizontal for any subsequent set in the same diagram. In the same diagram, don't use. So this is my A. So this is indicated. This is indicated. This is indicated. And this is A. And this part is vertical lines are B. Vertical lines are B. Yes. So the vertical lines are of B. Then what we should do? We have to calculate, find out, represent the union. Union is represented. Union means only A present, or only B present, or both present is union, no? So this is A union B. So what is the intersection? Intersection is both must be there. Both means the vertical as well as horizontal. So that is intersection, A intersection B. So here in this particular diagram, I have illustrated what? A union B and A intersection B. And this is mu now. This is mu. Now, if you observe, when you talk about the union, the entire overlapped circle was covered when under the union. This part is covered in intersection. Only this both this shape, this fish shape thing is the intersection. And also, other than this overlapping circles, the outside one is neither A nor B. In English, either A or B. Either A or B means only A or only B or both. Okay, this is the what A union B and A intersection B. The difference and other things I have done. So important point here is in solving the problems, the three set problems, it becomes imperative that you should know the area of each. The three overlapping circles are drawn, which I am going to do now. Yes. This is circles A, B, and C. So you check that in the fourth paper, last paper, this was presented. Whatever I am discussing is written on a paper and presented to you. So you can read it again. So in the fourth paper, you refer, this is termed as 1, this is termed as 2, and this is termed as 3, this is termed as 4, and this is 5, and this is 6, and this is 7. And if you are taking up the universal set, and this is 8 universal set, this is 8 part. Now I am giving you what? The numbers, no? Numbers. Now read from the paper, which is given to you. I will explain the regions. Read from the paper. Yes. Here you see the first part is common to all. Common to all is A intersection B intersection C. First part is common to all. A intersection B intersection C. The next part. The next part is what? The next part is second part. What is the second part which is exclusive for A and B? Which is exclusive for A and B? Mean what? They belongs to A and B, but not C. Only exactly AB, that is the word. A intersection B. When you take A intersection B, the region 2 and 1 is also covered. But you don't want 1. How to delete that 1? Take the C bar. Take a C bar. When you take C bar, what happens? You will have A and B, but not C. So similarly, the third numeral is here. The third numeral is containing what? A and C only. If you are talking about A intersection C, this this 3 and this 1 are covered, but you don't want 1. 1 belongs to what? B. So that B is deleted. Deleted part, you take it up as a B bar. Then Roman 4. Roman 4 is where? Here it is. That is the part which belongs to B intersection C. If B intersection C is taken, you will get 4 plus 1. 4 plus 1. But you want only 4. That's why the complement of A is chosen. Complement of A, not A. Yes. Then next what? Then next what we'll do? We will take up what we call 4 is done, no? 5. 5 is only A. 5 is only A, please. 5 is only A. 5 is only A. Only A. In A, what parts are there? Some part of B is there, some part of C is there, the common part is there. Yes? What is the 5? A must be there, no B and no C. No B means what? B bar. No B means B bar. Yes? Right. Then what is the 6th one? 6th one is only B. Only B. Only B means A bar intersection B intersection C bar. Yes? Intersection C bar. Only B. Then only A, only C. Where is only C? That is the 7th one. 7th one is what? Only C. Only C means you don't want A. If you don't want it, you take the complement. You don't want B, complement, and then intersection with C. Then what is the 8th one? 8th one is A union B union C. What is A union B union C? These overlapping circles. These overlapping circles are A union B union C. And for the 8th one is other than these overlapping circles. So that is neither A nor B nor C. So that is A union B whole complement. Okay. One more time we will explore. Then we'll go to the problems. So what is the first one? First one is A intersection B intersection C. That is the first one. And what is the second one, please? Second one. So from A intersection B, you are taking away the 3 intersection. So 3 intersection is you don't want a C. What is the third one, please? Third one is from A intersection B, from A intersection C, you are taking away B bar. And what is the fourth one, please? The fourth one is from B intersection C. From B intersection C, you are not considering A. So A bar, right? Then what is the fifth one? Fifth one is there, only A. So A intersection B bar intersection C bar. That is the fifth one. What is the sixth one, please? Sixth one is only B. Only B is A. You don't want. You want B. You don't want C. What is the seventh one? Only C. What is the only C? A bar intersection B bar intersection C. What is the eighth one, please? Eighth one is neither A nor B nor C. A union B union C. A union B union C whole complement. So this is the eighth one. Okay. Now the entire part what I have taught is given in papers. So I take up 2 minutes and go through the papers. and the difficulty concept which you are finding difficult, raise that concept so that I can address it. Yes, please. Yes. Now, take 2 minutes. Any concept is to be explained, express it through the chart so that I can explain. Otherwise, if everything is clear, I'll go to the problems. Take up 2 minutes. Go through the 4 papers, Venn diagrams. Yes, please. Can I go to the problems? Are you reading still? Better you read still. Any difficulty you raise? Fifth one. Ruchita, fifth one you are asking. Fifth one you are asking. Fifth one of what? In this diagram? In this diagram, fifth one? Respond. Is it in this diagram the fifth one or the fifth point? Ruchita, respond. Fifth one of the diagram. Fifth point. Okay, okay. Yes. The fifth point. Yes. The number of elements decide whether the set is finite or infinite. See, for example, if you are taking the number of students appearing for intermediate IPE examination, finite number of students will be appear. So what you do, you collect every student, you collect a set, you constitute a set which is consisting of the students of all the junior colleges writing IPE exam. That is the set. The number of elements of that set are finite. If you count that will end at one point. Imagine you are taking the natural number set. As long as you are counting, the numbers keep on appearing. Such elements are infinity. The elements infinity, the set containing infinite elements is a infinite set. Set containing finite elements is finite set. That's all. Okay, done. Can we go to the problems? Or yeah, read please. Read. Still any difficulties in the theory part you raise? De Morgan laws, yeah. De Morgan laws. There are two categories of De Morgan laws. One is the De Morgan laws of difference, and one is the De Morgan laws of complement. They are very important and play a very vital role in solving the problems on what? The probability. Okay, I'll explain the De Morgan laws. So first De Morgan laws of complement are addressed here. De Morgan laws of complement. De Morgan laws of complement. That is being addressed now. Yes. Now here, the first law says A union B whole complement is the same as A complement intersection B complement. The proof is taken up by the Venn diagram. This is A, this is B. Try to understand one thing. If you want A complement, if this is A, other than A, the outside part is A complement. What I shaded here is A complement. So what I will do here, I will shade A complement intersection B complement, and I will shade A union B whole complement, and I will show that the regions represented by these two things are same. Yes. If this is A, this is B. What is A union B whole complement? A union B whole complement. Other than these overlapping circles. What are these overlapping circles? These overlapping circles are giving you, what? They are giving you the union. A union B is given by what? A union B is given by the overlapping circles. And other than that overlapping circles, I have shaded. So this is this. Got it? Now, next, let me shade A complement. A complement, I will use a vertical lines. Whenever I am shading A complement, I should not shade A, except A, the outside part. Except A, outside part. This part can be shaded because it doesn't belong to A. That doesn't belong to A. So these vertical lines are what? These vertical lines are A complement. Now for B complement, let us use horizontal lines. Distinction for B complement. For B complement means you should not go for B, except B, the entire part is shaded. Except B, the entire part is shaded. B is left over. Right. So the B complement is the horizontal. Now, what you are talking about left side you are talking about the A complement intersection B complement, means both must be present. Both are present where? Both are present in this meshed region. So where is the meshed region coming? Is it coming here? No. Here only the horizontal are present. Here only the vertical are present. Here neither of them are present. So this is not coming, this is not coming, this is not coming. All outside this overlapping circles has come. So from this diagrams, you can see that the whatever the regions represented by this and this are same. Okay. As such, what should happen? A union B whole complement must be equal to A complement intersection B complement. Now let us take up the one more De Morgan law of complement. One more De Morgan law of complement. Let me take up. So one more De Morgan law complement is what? A complement, A intersection B whole complement is equal to A complement union B complement. So what is the left hand side? I will draw left hand side. What is the left hand side? This is A, this is B. Identify what is the A union B, A intersection B. This is the A intersection, this part. Other than that, the remaining part must be shaded. This is a diagram representing the left side, A intersection B whole complement. A intersection B whole complement means except the set in the base, the other part belonging to mu is taken. Yes. Now, next part is A complement union B complement. Union means only vertical is okay, or only horizontal are okay, or both are okay. So what is the region given? Only vertical, okay. Only horizontal, okay. Meshed, both, okay. So the entire region is coming, except where neither vertical nor horizontal nor this the meshed part is there. So this part is coming around. This part is coming around. Except this, the entire part is coming. This is also giving you the same, no, as such a this one will be happening. Now, De Morgan laws of difference. A minus B union C is equal to A minus B intersection A minus C. A minus B intersection C is equal to A minus B. Yes, union A minus C. These are the De Morgan laws of what? Difference. Tell me whether the complement laws are understood. Then we can go to the further. Read one more time. Other part, anybody having difficulty in the theory, you can raise. I will address it before going to the problems. Yes. Yes, please. Now, we are left with a little time, so that what I will do, I will try to explain the concepts of relations also, so that we can take up the problems in one go. Okay. Ruchita, okay, ma? Yes. Now, what we do, I will explain the concepts of relations, so that in one go we can do the problems. Concepts of relations. Because we are pressed for time, hardly we have some 10 minutes. Subsequently, one more class is also scheduled. So what I will do, whatever the time I am having, in that time I will discuss the concepts of relation. Yes, so that we can do the problems in the one session. Problems pertaining to what? Problems pertaining to sets as well as relations. Right. Now, you have explored the sets. Sets you have explored, no? Now what happens? Now, what we do? Now, what we do? Yes. Here, consider a set A. Consider a set A, which is non-empty. Non-empty means having at least one element in it. Another non-empty set B. Then they are constituting a thing known as Cartesian product. Cartesian product. So try to pay attention. The neve of the foundation of the function is laid from this only. The entire calculus origin point is set only. Set is the origin point. From set they have developed the relations. From the relations they have developed the functions. From the functions the subsequent application of the calculus have generated. So we are doing pre-calculus, you can say. Now Cartesian product. What is the Cartesian product? Cartesian product is nothing but collection of ordered pairs. Ordered pair. The ordered pair, the name itself implies AB is not equal to BA until and unless A is equal to B. So AB, yes, AB is not equal to BA. So A cross B, the Cartesian product of A and B, such that A belongs to capital A, B belongs to capital B. This is the definition. The definition will be clear if I take up one example. A cross B is equal to XYZ cross 1, 1, 2, 3, 4. Like that. I have taken up in two non-empty sets. So they will say, so X1, X2, yes, pairing X1, X2, X3, X3, and X4 is X4. Same Y1, Y2, Y3, Y4, Y3, Y4. Then Z3, Z1, Z2, Z2, Z3, and Z. So you have generated how many? 3 into 4, 12 ordered pairs. The set containing these 12 ordered pairs is known as Cartesian product of A and B. Okay. So two non-empty sets are chosen. First element is belonging to the first set. The second element is belonging to the second set. So you can have the ordered pairs. Such an ordered pair set is known as the Cartesian product. Now the relation will come to relation. So what is the relation definition? The relation definition is any subset of A cross B is any subset of A cross B is what? Any subset of A cross B is a relation from A to B. This is the definition. Example I will take up. Simple example I will take up. Yes. Check here. A is equal to 1, 2, 3. Simple one. B is equal to 4, 5. As we are illustrating, simple example. A cross B. What is A cross B? 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5. This is known as what? Cartesian product. Now I want to define a relation. So relation is to be defined. Relation from A to B. Such that relation from A to B, R, that relation is denoted by R, such that X comma Y ordered pairs, X belongs to A, Y belongs to B, X less than 1. This is a relation. I am generating a relation for sake of your understanding. So what is R consist of now? R consists of, what is R? R is X comma Y such that X belongs to A, Y belongs to B, X less than Y. This is the one. Got it? We are illustrating what? Yes. A relation is from A to B, X, Y, such that X belongs to A. You already found A cross B, no? In this A cross B, you pick out the ordered page in which pick out the ordered page in which the first element is the lesser than. First element is what? Lesser than the second element. What will come? 1 4 will come. 1 4 1 5 2 4 2 5 3 4 3 5 will come. All will come. So another R2 relation. What is R2 relation? XY such that X belongs to A, Y belongs to B, and X greater than Y. X greater than Y. Anyone, in any of the ordered page, are you finding X greater than Y? So this is a no elements relation. Now one more relation I can design such that, yes, a relation R3, mapping from A to B such that X comma Y, X belongs to A, Y belongs to B, and X divides Y. I can design a relation like that. X divides Y. So does 1 divide 4? Yes. So 1 comma 4 would come. First element should divide the second element. 1 comma 3 would come. Yes. 1 comma 5. 1 comma 5. 1 comma 5 will come. 1 comma 4. 1 comma 5 is okay. 2 4 divides. So 2 divides 4. The first element dividing second element. 2 divide 5? No. 3 divide 4? No. 3 divide 5? No. So only these 3 elements would come. Okay. Now this is the relation. So what we have explored first, we have explored Cartesian product means what we have explored. From this Cartesian product, don't worry about the jotting down the points. As of today, I will provide you with a synopsis sheet in the next class. So Cartesian product is done. Then what else we have explored? How the relation is defined. Now the relation is defined from A to B means any subset of A cross B is a relation from A to B. And then the number of elements of A cross B is equal to number of elements of A multiplied with the number of elements of B. In case of infinite set, either of A and B is infinite, we'll have infinite collection of ordered pairs. The best example for the Cartesian product is nothing but R cross R. Can anybody come up with what is the set of R cross R? You have already done it. R cross R you studied in deep. I will give you 1 minute. In 1 minute you come up with what is R cross R. What is R cross R? You studied. R cross R is what? Cartesian product of R with itself is giving rise to what? Anybody? Respond. Yes, yes. Somebody said. Yes. Okay, we have concluded. We have concluded. In the next session, we will do more. Sir, you can unmute me and start your logical reasoning class. I have done. I have concluded. I am waiting for Santosh to post something, but Santosh is waiting for me probably. So, sir, you can start your class. The logical reasoning class can begin. I have done my part.
Yeah. Okay, I'm trying to work that out. Yeah. Let me try to, I'm trying to share a screen and there's some problem. Yes. Are you able to see the screen? Are you able to see the screen and is my audio clear? Can you respond, please? Yes, good. Who is 1649920? Who is 1649920? Okay. Good afternoon, everybody. After a gap of almost a week or so, we are back. I'm going to take this English proficiency and logical reasoning forward. So far, we had, I think, about 11 classes of English where we tried to complete most of the English questions. What is now left is logical reasoning. Now, in logical reasoning, there are about 10 points. Now, let me quickly take you through those 10 subtopics. First is analogy. Analogy we have already covered in English, so more or less the same thing has to be followed here. Second is classification. Third is series. Fourth is logical deduction, and today's class is about logical deduction. Fifth is chart logic. All these 5 items form part of what is known as verbal reasoning. Then you have non-verbal reasoning. Non-verbal reasoning has to do with figures. So pattern perception, there are 5 items here. Pattern perception or completion of figures, figure formation and analysis, paper cutting, figure matrix, rule detection. So these are the 5 items as far as non-verbal reasoning are concerned. So what I'm going to do today is logical deduction is something which requires some kind of introduction, and there are a variety of questions that get tested. So we will do those questions today so that you are familiar with them. so that the questions that you will get in the part test and grant test, you should be in a position to answer. Most of the other verbal reasoning questions are very easy to tackle, and you should not have a problem. What I'm going to do is, after the class today, I will ask Anji to circulate these material for logical deduction, and that should actually help you. What you have to do is slowly, don't overdo it, as I said, take time, say about half an hour every day, and do one particular topic. And also share you a number where you can contact me for any doubts that you have in the material that is shared. Okay, so today we are going to do logical deduction, and next class I am going to take up some other items which require a little bit of elaboration. All the easy ones, I think it is something that you can handle yourself. Logical reasoning, especially students who come from maths background, should not have any problem in terms of doing logical reasoning questions, and you should be in a position to answer most of those questions very, very easily. Logical deduction today requires a little bit of introduction. So we will try to do that introduction. And at the end of the class, you should be very comfortable handling these kind of questions. So what I want today, as usual, is your total participation in the class, because you will learn only by participation. So I want everybody to give answers. So first of all, let me check up who's there in the class. So can you all identify yourself quickly? So please send in the chat box. Please send me your names. Kaushik is there. Very good. Who else? Quickly. I want to see who is there in the class today. Quickly. Anaga is there. Very nice. Bhagirath Reddy is there. Ruchita is there. I think after this is one of the first classes she's attending. Kiran Mai is there. Shreya is there. Shreya Reddy is there. Sindhura is there. All right. Who else is there? Quickly identify yourself. I want everybody to participate today. So you should all participate. Only by participating you will learn. Where is Dhanush? Where is Sudhanshu? Where is Supraja? Kiran Mai is there. Okay. Where is Tara? Where are the other people? We will see anyway. So let's go on. Today, what we're going to do is we want to see how a logical deduction question looks like. So first thing is that read this question. Let us look at an example. Please read this question, and I will come back and discuss the answer. Okay. So this is a question. Start from here. Earthquakes, volcanic eruption, and unusual weather. Start from there. Read the question carefully. Try to answer it. Then we will use this specimen to see what kind of questions you will be getting in logical deduction. Please read the question. I think that will make it more readable. Yes, are you able to? There's a lot of English there. Are you able to read it? And can you think of an answer? Okay, Shreya has answered. Okay, let's see. She has given some answer. Is Vishnupriya awake? I want her to answer. Vishnupriya. Is she aware? Is she awake? Okay, Shreya has given an answer. Now let's try to see how to answer this question, and thereby we will form the basis for answering all questions in logical deduction. Okay, first thing is always logical deduction question consists of three parts. One is a small passage or a set of sentences, then a question, and then options. So what we should do is always look at the option first, or always look at the question first, not the option. Always look at the question first, because if you read the question first, you will know what to search for in the passage given. So here the question says the conclusion drawn above is most seriously weakened if which of the following is true. So what are we going to do? We are going to search for a conclusion in the paragraph. So first, our job is to search for a conclusion, and then we'll have to see what can weaken the conclusion. So let us read this passage. Now, what does the passage say? Earthquakes, volcanic eruption, and unusual weather have caused many more natural disasters adversely affecting people in the past decade than in previous decades. All right. We can conclude that we are very fortunate because explicitly he is given the conclusion. In certain passages, he may not tell us the conclusion. We'll have to derive the conclusion. Here in this particular case, he's given us the conclusion. We can conclude that the planet Earth as a natural environment has become more inhospitable and dangerous, and we should employ the weather, etc., etc., etc. So he's saying the conclusion is that Earth as a natural environment has become more inhospitable and dangerous. So the conclusion is Earth has become more dangerous. Simple. In one simple sentence, if you want, the conclusion is Earth has become more dangerous. How is he arriving at this conclusion? He says more people are getting affected in the past decade than in the previous decades. His time frame reference is past decade compared to previous decades. So past in comparison with the previous decades. In the past decades, more people are getting affected because of natural calamities, natural disasters. Therefore, the earth has become more dangerous. That's all. So now we have to find a particular sentence which can weaken this particular conclusion. So the conclusion is based on the fact that more people are getting affected. So if I show that more people are getting affected by some other reason, not because of the earth becoming more dangerous, then it will become weakened. So we will see which of the options gives us that kind of a conclusion. Let's see. First one, the weather and earth sciences have proved better early warning systems for natural disasters in the past decade than in previous decades. Is this relevant to our conclusion? It is nowhere relevant. He says they have provided early warning systems. In fact, if you have early warning systems, you should have less people getting affected. So that is not the case. But anyway, it is not relevant to our main. So don't bother about one. Second, international relief efforts for victims of natural disasters have been better organized in the past decade than in previous decades. So when does relief happen? Relief happens after the natural disasters have struck. So as far as our main argument is concerned, this is also not relevant because relief efforts happen after the people are affected. So we are not even going, we are not examining this post facto. We are talking about people getting affected, and therefore earth has become more dangerous. So as far as our argument is concerned, second is also not very relevant. Let's look at the third one. The third one says there are records of major earthquake, eruptions, droughts, landslides, floods occurring in the distant past as in recent past. It is a decent option. You can consider this option seriously, except that he's talking about distant past as well as in recent past. We do not know what he means by distant past. We do not know what he means by recent past. Distant past could be 1 year back. Recent past could be last month. Whereas in the paragraph given, we are very clear about the time frame. Past decade, previous decades. So he's talking about 10-year intervals. So this distant past as well as recent past are time frames which are a little ambiguous, and therefore this cannot be considered seriously. Let us look at the fourth one. What does the fourth one say? Fourth one says population pressures and poverty have forced increasing numbers of people to live in areas prone to natural disasters. Now let's look at this a little more seriously. What's he saying? Earth has not become more dangerous. It is just that more people are living in areas which are prone to natural disasters now. And because more people are living in areas which are prone to natural disasters, as a natural corollary, more people are getting affected. It is not that the earth has become more dangerous now. It is just that more people are getting into areas, are staying in areas which are struck by natural disasters. And therefore, we are finding it not become more dangerous. It is just that more people are staying in those areas where the natural disasters occur, and therefore we are finding more people getting affected. Therefore, you see the fourth sentence weakens the conclusion has been provided. What is the become more dangerous? Has become more dangerous because more people are getting affected. Now, fourth statement, fourth option gives us a reason as to why more people are getting affected. Not that Earth has become more dangerous. Earth has remained the same. It is just that more people are staying in areas which are prone to natural disasters, and that is why more people are getting affected. So, therefore, option fourth weakens the conclusion that is provided. So why I have given this particular example is to look at the logical deduction question and to see how we can tackle these kind of questions. So to summarize, logical deduction questions contain three parts. Part one is a paragraph or a set of sentences. Part two is the actual question. And part three is the options. So how do you tackle this question type? You should look at the question first, then look at the paragraph, the sentences given, and then try to answer the options. So this is a technique that we will be using as far as the logical deduction questions are concerned. Kaushik asks, will they give lengthier questions? But as far as Bitsat is concerned, there is no particular what would I say, a format in which the questions appear. The database, they keep adding all kinds of questions. So they will give lengthier questions. Reading comprehension is a lengthy question. Don't you find reading comprehension lengthy questions? So also in logical deduction also, we may come across, or we will certainly come across lengthy questions. So you need to take a call in when you approach a lengthy question, whether you should answer it at that point of time or you should defer it. But point is, the questions are very simple. If you read the question properly, it becomes more or less like a reading comprehension question with a little bit of logic. Now let's try to do this exercise. Let's try to answer this question. Please try to answer this question and we will see. The question is very easy. You just have a question and it's more like a reading comprehension question. Please answer this. Yes, Shreya has answered it. Fantastic. Very good. Shreya has answered the question. Shreya has answered the question. Where are the others? Sai Lakshmi Priya is not there today. She has given up on Bitsat or what? Kaushik has answered the question. But let's try to look at the that Kaushik has given. Bhagirat, what about you? What about Rishita? What about Nalini? Who is Nalini? What about Vishnu Priya? What about the other silent types? Sindhura, Anaga, where are you? Please answer this question. It's an easy question actually. It's not a very difficult question. Are you able to read it in the first place? Please answer. Just try. You don't by answering. Ruchita, you got to answer this question, please. You don't lose anything. Yes, Ruchita has answered. Fantastic. Kiranmai, we are waiting for your answer. Shreya has answered. Shreya Reddy has answered. Bhagirath has answered. Rishita has answered. Kiranmai has answered. Very nice, all of you. Good attempt. Okay, now let's try to look at this question. What is the question? The question is, what is the main idea? Simple. We've already discussed this in reading comprehension earlier. When you're looking at main idea questions, there are a couple of things that you should do. You should find out who's the hero of the passage. Second is, what is being said about the hero? I also said, while we're discussing reading comprehension, I also said, if you're lucky, you may get a topic sentence. And topic sentences will give you a clue as far as what the main idea is concerned is. So if you see, fortunately, here, there's a topic sentence in the paragraph. In the first part itself, what does it say? There is a strong relation between limited education and low income. You don't even have to go any further. Your answer is here. There is a strong relation between limited education and low income. Now tell me what is the answer. Now everybody, tell me what is the answer. Now what is the answer? Kiranmai, what is the answer? Bhagirath, what is the answer? Anaga, yes, you got it. What is the answer now? Shreya Reddy, what is the answer? Okay, yes, Ruchita, you got it right. Shreya Reddy. It is given, Amma, it is given straight away there that there is a strong relation between limited education and low income. What does that mean? It means if a person is less educated, his income is also going to be less. Straight away is given. There is a strong relation. All right. You don't even have to look further. The rest of the paragraph, it just describes this. Statistics show that unemployment rates are the highest among those adults who attend school the fewest years. That also says the same thing. Okay. Most jobs in modern industrial society require technical or advanced training. So if you don't have that kind of training, you will not get a job. The best pay goes with jobs that demand thinking and decisions based on knowledge. A few people manage to overcome their limited education by personality or a lucky break. However, studies of lifetime earnings show that average high school graduate earns more than the average high school dropout, who in turn earns more than the average adult who has not finished 8th grade. So all the statements point out to the fact that if you are less educated, your income is also going to be low. Therefore, I mean, it's a straightforward thing. I mean, there's nothing ambiguous about this particular thing. Less educated a person is, less is his income. And also, if you see, there is that topic sentence which gives a clear clue as far as your answer is concerned. You can't go wrong in these kind of questions. So this is the first question. Now let's look at a second kind of a question in logical deduction. Now let's see how you will answer this. Please answer this question. If all the above statements are true, which of the following must also be true? Let's try to answer this question. Please try it. Let's see how you will try it. Shreya has given some answer. Let us see. Shreya has given some answer. Rishita has given some answer. Ruchita has given some answer. Let us see how to do these kind of questions. Kaushik has given an answer. Okay, let's employ some very simple techniques to answer this question. What he is saying is, and please concentrate, everybody please concentrate on the board. Some poets are creative. So let's try to represent this relationship. Some poets are creative. So this is poets. This is set of people who are creative. This set of poets, set of people who are creative. Can I represent like this? Some poets are creative. Do you all agree? Some poets are creative. I can always represent like this. Good. Now, all creative persons are eccentric. All creative persons are eccentric. So how am I going to draw that? Like this. Okay. So this is E. E means set of eccentric people. All creative persons are eccentric. So eccentric is a bigger circle and creative people will be part of it. So this is how I can represent it. Next he says, all poets enjoy music. All poets enjoy music. So people who enjoy music, I can draw like this. Enjoy music. EM means enjoy music. People who enjoy music, I can represent this way. Now let us try to answer the question. He says, first option is, no poet is eccentric. Is that true? Cannot be true because there are certain poets here who are eccentric. There are some poets here who are eccentric. So you can't say A is right. So there are some poets who are eccentric. Okay, so that is not true. So let me take this out. Okay, now let me come back. Let me look at B. All those who enjoy music are eccentric. All those who enjoy music is set. All of them are the eccentric? No. Why? Because only some of them, only these people are eccentric, not all of them. So second statement is also not true. A is not true, B is not true. Are you following why B is not true? All those people who enjoy music is this bigger circle. All those people who are eccentric is this circle. So these two, the people who enjoy music is not part of the circle which represents people who are eccentric, and therefore we cannot say all those who enjoy music are eccentric. That is not possible. Now let's look at C. Some of those people who enjoy music are eccentric. That I can definitely say, because there is this set of people who enjoy music and who are also eccentric. So this part is fine. So some of those who enjoy music are eccentric, and therefore answer is C. And most of you have got it right. That is a very good thing. So whenever you have these questions, all you need to do is draw these Venn diagrams. You draw these Venn diagrams, you will know how to represent the sets. There is one more question, slightly more complicated question than this. We will apply the same technique in terms of answering the question when we approach that particular question. And I hope all of you understood this. Now let's go on to the next kind of logical deduction question. Okay, let's look at this question. Please try to answer this. Please try to answer this question. Okay, Shreya has answered this question. Okay, not a very difficult question. You just have to read the first paragraph only. All right, because the question pertains to the first paragraph. That is why I keep saying, read the question first. Read the question first. Only Shreya has answered. What about the rest? Anaga has answered. Anaga, we are dealing with only the first paragraph. Rishita has answered. Very good. Very good, Rishita. Who else? Harshit is very silent today. Kiran Mai, yes. Good. Good, Kiran Mai. What about Harshit? Okay, let's see. Let's see the question and let's try to answer this. Okay, the best conclusion, the question is this. The best conclusion that can be drawn from the first paragraph is that after election. So we'll have to concentrate on the situation after election. So the candidate who wants to be elected pays close attention to statements and actions that will make the voters see him favorably. In ancient Rome, candidates wore pure white togas, like in India. In India also people wear khaddar, to indicate that they were pure, clean, and above any dirty work. However, okay, now this however is very interesting. That means that there is some conditionality attached to it, and whatever comes after however, you need to concentrate on it. So however, it is interesting to note that such a toga was not worn after election. So very simple. I think even Roman times, politicians were not different. So before the elections, they were bothered about impressing the voters. And after the election, they won't care about what the voters think. Okay. So it is interesting to note that such a toga was not worn after election. Why was it worn before the election? Because they wanted to indicate that they were pure, clean, and above any dirty work. So after election, these things are not important. So therefore, they don't wear. So what is the answer? Therefore, the best conclusion that can be drawn from the first paragraph is that after election, all candidates, now this is a sweeping generalization not supported. A, all candidates are dishonest. That is not implied by the paragraph. Candidates are less concerned with symbols of integrity after elections. That is why, see, why are they wearing before the elections? They are wearing before the elections because they want to show that they are pure, clean, and honest. What is integrity? Integrity means honesty. Please understand, integrity means honesty. So they want to indicate that. That is why they were wearing before the elections. But after the elections, after the purpose is served, now they are not bothered about it. And that is why they don't wear the togas. So on the basis of the first paragraph, we can conclude that candidates are less concerned with symbols of integrity after elections. Okay, let us go on. That's a very easy question. You can't go wrong there. Let's go to the fourth one. Please answer the fourth one now. Are you able to see the fourth one? Please answer the fourth one. Everybody has to participate. You can learn only by participating. So don't expect any pearls of wisdom from me. It is by participation that you will learn. This is not some geography or sociology or public administration that I give you a lengthy bhashan and you get something. You learn by participating. You participate, you learn. You don't participate, you don't learn. As simple as that. Okay, it can be inferred that most candidates from the same political party today are likely to. Harshit has answered. Okay, Bhagirath has answered. Okay. See, one thing in logical deduction you got to be careful is the kind of conclusions that you draw have to be, yes, Shreya, I've seen you've answered. Yes, you answered, I know. So the conclusion that you draw must be supported completely by the statements given in the paragraph. Now, I will, to demonstrate this particular aspect, let me give you one example. Please listen to the example that I am stating right now. Everybody concentrate on what I'm saying. It is not on the screen. Please concentrate on what I'm saying. 3 friends have come out of a railway station in a strange town, and they saw a red car going by. They saw a red car going by when they came out of the station in a strange town. The first friend said, all cars in this town are red. Can we conclude this? Is this statement made by the first friend? All cars in this town are red. Can it be supported on the basis of whatever they have seen? That is what the first friend says. And Shreya says, yes. No, sir. Correct. What Shreya says is right. You've seen one car. And on that basis, you cannot conclude that all cars in this town are red. Then the second friend says, some cars in this town are red. He says, some cars in this town are red. Can we say that this statement is correct? Ruchita says yes. Shreya says no. All right, good. So we have some interesting answers here. Ruchita says yes and Shreya says no. And let's examine this. He says, some cars in this town are red. Now, what has he done? He's used a plural there. He said some cars. What is the example they have? One car. But what is he trying to do? He is generalizing what he is seeing. Okay. So the third friend, perhaps who's clear about his logical deduction capability, has come up with the statement. And that statement is, there is at least one car in this town which is red. There is at least one car in this town which is red. So which is the most logically consistent answer? Obviously, that third one. Obviously, the third one. So this is what we have to be careful about while answering logical deduction questions. You should always be careful about what you can infer and don't go for sweeping generalization. Yes, Ruchita, in the example that I gave. Okay, so whatever conclusion that you come up with should be supported totally in the passage. Now, let us look at this question. It can be inferred that most candidates from the same political party today are likely to what? Let's see the second paragraph. In modern history, I'm reading this. In modern history, candidates have allied themselves with political parties. Once a voter knows and favors the views of a certain political party, he may vote for anyone with that party's label. Nevertheless, division of opinion develop so that today there is wide range of candidate views in any party. There is a wide range of candidate views. So it is not necessary that the candidates in a political party all agree to one particular viewpoint. They may agree on some points, they may not agree on some other points. Some may agree on some points, some may disagree on those points. So if you see, A says have the same views. This is a generalization not supported in the passage. So this can't be the answer. Yes, Ruchita, now you see, now you got the answer. Your thinking is correct, is on the right track now. Be different in every view. Every view. Is that right? No, it is not right. He says they agree on some, they disagree on some. Agree on almost all points. That is also not true. He's saying that they agree on almost all points. No. So what all that can be supported is agree on some points and disagree on others. So logical deduction is all about concluding with precision. That is what you should do, like what we have done in today's paragraph. Let us go on to the fifth question. This is another type of a question where we are trying to find out an error. We are trying to identify an error. So please read this question and try to answer this. Please read this question. In fact, by answering this question, we will identify two common errors, two common logical errors that people make. Both are important. The question concentrates only on one error, but we'll identify two errors. Shreya has answered. Okay, Shreya, let's consider that. Okay, Shreya, that's right. Actually, that's what I was saying, that there are two errors in this. And this particular question concentrates only on one error. So we'll have to see what is he bothered about. But let us identify both the errors, and you have identified both the errors. That's right. Rishita has answered. Rishita has answered. Okay, let us see Rishita. Anaga has answered. Oh, Anaga has answered. Okay, Anaga. Okay, that's an error, all right. But we need to concentrate whether, we need to focus on whether that is what he is looking at, whether Lakshman is concentrating on that. The error is all right. Anaga, the error that you have pointed is all right, but we need to check up whether Lakshman is focusing on that. Okay. What about Kaushik? What about Bhagirath? Harshit, where are you people? Please try. See, because after I give the answer, it looks simple. First, you have to try. Then you will find out how to make logical deductions. Yes, let's see. Any other answers? Kiran Mai has gone to sleep. Ruchita, answer. Try it. You don't lose anything by trying. Just try it. It's not very difficult. Just try it. Just try, madam. Yes, Ruchita. You got an answer. Good. So let's see. Now, what is the question? The question is, which of the following best describes the weak point in Ram's claim on which Lakshman's response focuses? So what is Ram's claim? First, let's understand what's Ram's claim. And second is, we will identify what is the weak point in Ram's claim. And then we will go to Lakshman's response. The profitability of BML restored to private ownership 5 years ago is clear evidence that business will always fare better under private than under public ownership. So what can we understand from this sentence? That BML was first a public company. Public company means owned by the government. Then 5 years back, it has become a private company, and it is now profitable. So he says, he concludes on this basis, that businesses will always fare better under private than under public ownerships. Okay, so there are two problems with this kind of a logical argument. Please concentrate. Everybody, please concentrate on this. Very important. There are two errors in this particular statement. First error, most of you identified. What is the error? That he has taken one particular example and he has generalized on that example. You know that in maths, to prove a particular statement, you have to consider all cases. That is how you prove your theorems. In maths, you know that. To prove a particular statement, you have to consider all cases. But to disprove that, one case is sufficient. To disprove a particular statement, one case is sufficient. But to prove, you have to consider all cases. Now, in this particular case, Ram has taken only one example, BML. And on that basis, he is trying to conclude. So this is flaw number one. This kind of an error in logic theory is called generalizing an analogy. Generalizing an analogy. Analogy is an example. So generalizing an example. So he's taken one particular case and he's generalizing on that basis. So that is one error. But is that the only error that is there in this argument? There is one more error. That error is he is confusing correlation with causality. Now let me explain that. He's saying that this has happened before. It has become private before 5 years, and therefore it has become profitable. Who knows? There may be other reasons because of which it has become profitable. May not be because of this privatization. So just because an event has occurred before this, that event cannot actually result in this kind of a situation. Just because an incident happened before doesn't mean that that event has actually led to this particular situation. Okay, like what? Now let's look at Lakshman. Now what does Lakshman say? Lakshman says, a close look at the records show that BML has been profitable since the appointment of a first-class manager, which happened while BMS was still in the public sector. So the actual reason is something else. The actual reason is that this manager has come in and has changed the whole operations of this company, and that has happened when it was still in the public sector. So to conclude that private sector privatization leads to profitability is wrong. So Lakshman is not concentrating on the first error. Lakshman is concentrating on the second error. And what is the second error? The second error is given here. Ram's statement leaves open the possibility that the cause he cites came after the effect he attributes to it. The cause he cites came after the effect he attributes to it. So therefore, just because an event has happened before a particular result, it is not necessary that that event causes this particular result. So answer is this. Shreya has got it right. Lot of you have identified A. A is also an error. A is also an error. I agree with you. A is also an error. But Lakshman is not concentrating on A. Lakshman is actually concentrating on C. And therefore, the answer is C and not A. All right. So let us see if we have more examples of this kind, we will become more comfortable with this kind of questions. Right. This is a very simple question and I want a very fast answer. Rapid fire answer. Please answer this quickly. Please answer this quickly. Rapid fire. Shreya has answered. Okay, but you have to look at your answer. Ruchita has also answered. Ruchita has also answered. Let us see if that is right. Ruchita has answered, Shreya has answered. There are others. Why are they not answering? You have to participate. There is no right or wrong answer. You will learn only by participating. Please give the answers. Don't sleep. Please give the answers. Rishita has answered. Okay, very good. T. Rishita has answered. Anaga has answered. Wow, Anaga. You got it right. Anaga has answered. Very nice. Bhagirath has answered. Okay. Bhagirath has answered. Okay, let's see. Who else? Ashreya has answered. Okay, Ashreya, congrats. That's the right answer. That's good. That's the right answer. Okay, now let's see. What is the question? The question is, which of the following is a basic assumption underlying Truman's statement? Kiranbhai has answered. Very good. Got the right answer. In his first message to Congress, Truman said, the responsibility of the United States is to serve and not dominate the world. Okay, we want to serve. We do not want to dominate the world. Okay. Now, a lot of you have given B as the answer. A lot of you have given B as the answer. What is B? B is actually a restatement of Truman's statement. It's a restatement. Truman said the responsibility of the United States is to serve and not dominate the world. What is B? The United States chooses to serve rather than dominate the world. Is it an assumption? It is not an assumption. It is a restatement of the given statement. Assumption is you made a conclusion. All right. You made a conclusion. Anything which comes before the conclusion, which supports the conclusion and not stated explicitly, is an assumption. Assumption is a set of statements which have to come before the conclusion to support the conclusion and which are not stated explicitly. It is not given explicitly, but unless you make that statement, you can't make the conclusion. That is an assumption. So assumption is a statement which is required to make a conclusion, but which is not stated in the paragraph. That is an assumption. So on that basis, if you see, Truman is saying, I don't want to dominate the world. But how do you know that he can dominate the world? He's assuming that he can dominate the world. So assumption there is United States can dominate the world. If that assumption is right, then what Truman says can be concluded. Truman says, we will serve and not dominate. So first is, can you dominate? So that is the point. So he is assumed that they can dominate. Only then you can come up with this kind of a statement. And therefore, the answer is the United States is capable of dominating the world. Some of you, Ruchita also got it right. You've got the answer. A. B is not an assumption. B is a restatement of Truman's statement. I hope you understood that. B is a restatement of the statement given. It is not an assumption. All right. Okay, let's go on. Let's go on to seventh one. Seventh one is a very important one. Very important in logical deduction questions. Please try to read it and try to answer it. and concentrate on this. Kaushik, these are short questions. You should be in a position to answer. These questions are not long. In fact, you will get longer questions in Bitsat. These are very short questions. Anaga has answered. Anaga, you are very fast to answer, but just check whether that is the answer. May not be the answer. Let's see who else has very clear thinking. Please answer. Rishita has answered. T. Rishita has answered. Okay. But Rishita, let us wait and discuss this. This is a very important question. Shreya has answered. Oh my God. Bhagirath has answered. Okay, let's see. Bhagirath has answered. Anaga has answered, has changed her answer. Has changed the answer. Okay, not. Let's see. Anaga has changed the answer. Okay, let's see others. Kiranmai, Ruchita. Let's see if they can answer. Okay, we don't have too much time. Let's try to answer this question. Yes, Ruchita has answered. My God, Ruchita, you got it right. Fantastic. You got it right. Okay. Now, if the statement above is true, which of the following must be true? So we need to consider. Shrestha, after a long time, you've woken up and you've come up with the right answer. Congratulations. Okay. Which of the following must be true? Every member of the Bombay cricket team in the Ranji Trophy who wears wristbands when batting wears either red wristbands or white wristbands. Let's try to put this correctly on paper. He says, if you wear wristbands, then you either wear red wristbands or white wristbands. Let me put it here. Wristbands. If you wear wristbands, it implies either red wristbands or white wristbands. This is or, you know this. This is or, that is or. Right wristbands or red wristbands or white wristbands. Okay. So this statement is of the type A implies B. This is an implication statement. A implies B. This is called an implication statement. So when A implies B, what it means is if A is true, B is true. If A is true, B is true. If A is not true, what about B? Can you say anything about B? Give me the answer. If A is not true, can you say anything about B? Can you say B is not true? Can you say that? Please answer that. If A is not true, can you say B is not true? Please answer this. If A is not true, can you say, whatever it is, Shrestha, please answer this question. If A is not true, can you say B is not true? Can you say that? Can you say that? A implies B is there. Yes, Shreya, you got it right. If A is not true, you can't say that B is not true. All right? Be very clear about this. But I can say one thing. Yes, Ruchita, you got it right. If B is not true, okay, if B is not true, then A is not true. You know that it is called contrapositive. If B is not true, A is not true. That we can say. Correct? Yes or no? Yes, Ashray has said that. Yes. If B is not true, A is not true. It is called the contrapositive. That you know. Similarly, if B is true, Can you say A is true? Can you say A is true? If B is true, can you say A is true? Please answer that. If B is true, can you say A is true? No, you cannot say that. So, correct. Ruchita has answered it. Shreya has answered it. Both of you answered it. Very good. So, you understood an implication statement. A implies B means the only thing that you can conclude from it is if A is true, the other thing that you can conclude is the contrapositive, and the contrapositive is if B is not true, A is not true. These are the two things that you can conclude from an implication statement. Okay, so let us rub this off. Okay, let me give an example. If Ram takes an RTC bus, he is late to the class. If Ram takes an RTC bus, he is late to the class. All right. If Ram takes an RTC bus, he is late to the class. He is late to the class today. He is late to the class today. Has he taken the RTC bus? Can you answer that? He is late to the class today. Has he taken the RTC bus? Are Shreya, why maybe or may not be? Can you answer or not? That's all I want to know. Can you answer or not? Yes, sir. Hey, mama. We have, after listening to entire Ramayana, you are coming up with this question. A implies, yes, Rishita, you got it right. A implies B means there are only two conclusions that you can make. If A is right, B is right. Or if B is not right, A is not right. So let me put my statement in A implies B. Ram takes RTC bus implies he is late. A implies B. All right. So now what is it that you can conclude? Today, all right, today Friday, Ram has taken RTC bus. So today Friday, he will be late to the class. That you can definitely say. Now today, he is late to the class. Let us say, today, he is late to the class. Can you conclude that he has taken the RTC bus? No, you cannot conclude. You cannot conclude. B implies A is not right. Okay. Okay. What can you conclude? He is not late to the class today. He is not late to the class today. What can you conclude? Ram has not taken the RTC bus. That is possible because that is the contrapositive. Ram is not late. Ram is not late. All right. Ram is not late implies Ram has not taken the RTC bus. That I can say. That is the contrapositive. So please understand. Yes, have you understood this or not? This implication statement you should understand clearly. Lot of logical deduction questions on this. Implication statement. Is this clear or not? Yes or no? Yes. Shreya has got it. I hope all the others have also got it. If you have not got it, play the video again and try to understand it. Okay. So when a statement is given, A implies B, the only thing that you can say is if A is true, B is true, or when B is not true, A is not true. No other conclusion can be supported. Okay. So now let's go back to our example here. What is our example? Our example is that every member of, so if he wears a wristband, he wears either red wristband or white wristband. That is all. Now please answer the question. In the light of what I discussed, please answer the question. Rishita has got it right. Rishita has got it right. Who? Whatever. Shreya has got it right. Fantastic. Shreya has got it right. Okay. What about the rest? Now you answer. Anaga has got it right. Anaga, now did you understand why your earlier answers were not right? Ruchita has understood. Ruchita has got it right. Fantastic. What about the rest? Okay. So let us look at the examples that we have here. A member of the Bombay cricket team who does not wear red wristbands while batting wears white wristbands while batting? I do not know. If he does not wear red wristbands, there are two possibilities. That he may not be wearing wristbands at all. They may not be wearing wristbands at all. So I can't say for sure that he is wearing white wristbands. So if he is not wearing red wristbands, there are two possibilities. Possibility number one, that he is wearing white wristbands. Possibility number two, he is not wearing any wristbands. So I cannot conclude that one is right. Have you understood this or not? If he is not, we only know that if he is wearing a wristband, he should wear either red or white. If he is not wearing, I don't know. All right, if he is not wearing. So if he is not wearing red wristband, I do not know whether he is wearing white wristband or he is not wearing any wristband at all. So first one cannot be concluded. 2, no member of the Bombay cricket team wears blue wristbands while batting. That is supported. Why? Because if he is wearing a wristband, it has to be either red or it has to be white. It cannot be blue. So definitely I can conclude that 2 is right. 2 is definitely right. What about 3? Some members of the Bombay cricket team do not wear wristbands when batting. I do not know. The statement only says that if they wear a wristband, then it has to be red or white. I do not know whether they wear, whether they not wear. If they wear, it has to be red or white. I do not know whether they wear or whether they do not wear. So this also I cannot say. So the only thing that is possible is 2. I hope you all understood it. Yes or no? Please answer it. Have you understood it? Yes, Ruchita, you've understood it. Good. What about the others? What about Shreya Reddy? What about Shrestha? Yes. Good. What about Bhagirath? Because this is very, very important in logical deductions. This kind of thinking you need to develop. All right. Very, very important. So anyway, we are running out of time now. If you've not understood this, please play the video again in YouTube and try to get what I'm trying to say here. Now let's look at the next one. The next one is yes, follows this. Let's try to answer this question. It follows the 7th question. Please answer this question. Please answer this question, the 7th question. Shreya has answered. Shreya, look at your answer, madam. Look at your answer. Look at your answer. Look at your answer, Shreya. What about the rest? What about the rest? Shreya, look at your answer. Anaga, what is the answer? Yes, Shreya, you got it right. Ruchita, your answer. Where did you get that answer? Okay, we are running out of time. I don't have time to give to everybody. So let's look at this. He says, in addition to the data given in question 7. Question 7, what is the data given? If somebody is wearing a wristband, it is either a red wristband or a white wristband. That is what is given in question 7. Now in question 8, he says further, if any player in the Ranji Trophy matches who wears red wristbands while batting also wears blue batting gloves. So he says, if you are wearing a red wristband, you also wear a blue batting gloves. Blue batting gloves. So that is the principle. But he also says, no member of the Bombay cricket team wears blue batting gloves. Nobody is wearing blue batting gloves. This is an implication statement. A implies B. Kiran Mai, just concentrate here. Kiran Mai, concentrate here. You got the wrong answer. What is the implication statement here? Red wristbands if you wear. Ruchita, you got the wrong answer. Please concentrate on my answer, on my explanation now. This is an implication statement here. Red wristbands if you are wearing, you will wear blue batting gloves. But Bombay cricket team fellows do not wear blue batting gloves. It is of the form A implies B. If B is not true, then what is true? If B is not true, then what is not true? A is not true. If blue batting gloves they are not wearing, then they are not wearing red wristbands also. Let us be clear about this. Bombay cricket team fellows, because they are not wearing blue batting gloves, not B, therefore not A. Not A means they are not wearing red wristbands. Okay, so this option is ruled out. So we can restate this statement as, if Bombay cricket team people are wearing wristbands, they are wearing only white wristbands, because red wristbands is ruled out. So if Bombay cricket team people are wearing wristbands, it is only white wristbands. So what is the answer? The answer therefore is, every member of the Bombay cricket team who wears wristbands wears white wristbands when batting. So this is the answer on the basis of whatever we have discussed. Bhagirath, yes, you've got the answer. Ruchita, now you've got the answer. Anaga, now you've got the answer. Fantastic. You are following what I'm trying to say. We have discussed some very important principles today. We have discussed only 8 questions, but some very, very important points that we have discussed. If you have not still followed 100%, play back the YouTube video and try to understand these questions. We will carry on this discussion in the next class. Also, Anji, I've instructed to pass on this logical deduction material to all of you. So I'm going to take another couple of sessions in logical deduction, not logical deduction, logical reasoning. I'm going to take a couple of more sessions in logical reasoning, and we are going to conclude. Next class will be next alternate day, Monday. So we're going to conclude on that basis. The rest of the stuff you can try on your own. And I am giving my number. This is the number that I have. Please send me a WhatsApp. 900007761. If you have any questions in the material that I've sent for logical deduction, not just logical deduction, logical reasoning, if you have any questions on that, I will answer those questions. Okay, so next class is on Monday. We will meet in the next class. Till then, have a good day. Okay. Santosh, you can stop the class now.